Hi all, we'll start the class shortly. Yes, hi all. How are you all? Very good afternoon to one and all, and welcome to our YouTube channel, Math Universe with Dr. Naseer Ahmed. How are you all? How is the preparation going on? How is the studies going on? Yes, Seven has joined. Can people, kindly mention your name? I would like to know who have joined. Please mention your name in the chat box and from which college you belong to. Till then, I'll just fill the ink. Kindly come in fast. We'll start with the class. Yeah, hello. Kindly comment. I would like to know the name of the students joined, from which college. Today 10 have joined. Let I fill the ink and kindly mention the college name. I would like to know. So far, Muhammad Yunus, followed by okay, fine. Okay. Yes, Muhammad Yunus, followed by Radhika Milin from PUC College, Gulbarga. Oh, great. We're having students from Gulbarga also. Ram Patil from Diamond Group of Institution. Basava Kalyan. Then Noor. Okay, fine. Okay, fine. How are you all? How is the preparation going on? How is the preparation going on? Yes. Hi, Pratham Pai. Okay. Yes. Okay. Preparation is going good. Okay. Have you people watched the other live session or gone through the recorded videos? What is your feedback? How the videos have been? Is it helpful? Or any comment you have? Yes. Any comment you have? I think now differential equation followed by vector 3D and probability. One of these four chapters are pending. Hope so coming this week it will be done. And then I'll be also going with the CET. Already matrices part 1 is uploaded, part 2, and then we'll go ahead one by one. Okay, one doubt. Yes, Satya, was a doubt? Satya. Nothing. Okay, fine. So fine, let us start with the class now. Okay, as you are aware, today we are dealing with. Okay, fine. Again, I welcome you all to our YouTube channel, Math Universe with Dr. Naseer Ahmed. Today we are dealing with the chapter matrices, determinant, and inverse trigonometric functions. And for all this, we are dealing with one marker, both fill in the blanks as well as MCQ, multiple choice questions. So the content is again taken from question bank issued by KESAV, okay, from PU board. And the main intention to go ahead with this is, what about those one marker? Because we want 80 on 80, correct? No? And surely the way the question is framed, no, it is also going to helpful for CET as well. Now let's start. First, what I will do, I'll go ahead with matrices. Quickly, let us recall the concept of matrices and then we'll start with the problems. Okay, fine. So this is fine. Yeah. So I have a line here. Yes, about that I should not write. Fine. So now we are dealing with the chapter matrices. A quick recap, fast we'll finish. What is a matrices? Matrices is a plural. Matrix is a singular. It is arrangement of number or elements or functions in a particular order. And we are going to have rows and columns. The arrangement which is done in this manner we call rows, horizontal which we call, and vertical we call columns. Both rows and columns together constitute the order of a matrices, and which we write as m cross n, or m by n we read, or m cross n we read. M stand for number of rows and n stand for number of columns. And whichever the matrix we try to write, we write a small letter in general, and all the matrices are denoted by capital letter A, and either a rectangle bracket can be given or a small bracket is also given. Okay. Now usually take this one. Fine. Now, having this, let us recall some of the things like what is the condition for a matrix. Okay, before that, the order of the matrix is m cross n. Number of element is given just by multiplying order of the matrix. After you multiply order of the matrix, you can get how many element do we have in that particular matrices. Okay, so having this, let us start with the problems. Before proceeding, Any doubts? So CET online classic. I didn't understood, Vivek, what you mean to say. I'm going to start with the class. Before proceeding, any doubts? Shall we go ahead? And the question numbers I have written same as the problem, means question bank issued by KSAB. So we are dealing with all the problems with the KSEAB. So now we are with only 1 markers. Let us start one by one. As and how I will go ahead with the problem, we are going to, I'm going to read the question. Okay, in case option required for that particular problem, then I'll provide the option. And after this live session is over, then I'm going to share this content as well. Okay, now let us first start with the problem. We are dealing with matrices. I have selected around 39 questions, including the assignments on matrices. Now I will read the question. I would like you to involve along with me. For each problem, I'll give you some 15 to 30 seconds because coming to matrix is not so lengthy solution we have got. After that, I'll try to comment. Okay. Now the first question from matrices is, if A is a matrix of order 3 by 4, A is of order 3 by 4. I'm just going to write below the letter of the matrix. No, I'm going to mention the order in place of in the usual way because we just want the solution of the presentation. Okay. Then each row of A has how many elements? Option A 3, option B 4, option C 12, option 7. Means I mean to say option D 7. How many elements it has? Come on, think. If A is 3 by 4 matrix, each row will have how many elements? Okay, Ananya says 4. What about rest? Harini says 4. Remaining, involving in the class is very important. Okay. Naseer also says 4. Fine. Let us try to understand. See, this question says we have got 3 rows and 4 columns. Just try to make 3 rows. I'm not needing any elements. I just want 3 rows. Yeah, first row, second row, third row. And 4 columns. First column, second column, third column, and fourth column. Now coming to each row, you see 1, 2, 3, 4. So each row will have 4 elements. So option blue is correct. Yes, you are right. Good job. Good job. All Ananya, Harini, Naseer, and Vivek Rathod. Yes, correct. You are right. Moving on to question number 2. I will read the question. Listen. If every row of a matrix A has m elements, understand, we have a matrix A and every row have got m elements. M elements we have in row, every row, and its column contains n elements. N elements are present in what? Each of the column. Then they're asking order of the matrix is. What could be the order? Yes, let us see how many. This actually is a replica of question number 1 only. Let us see. If matrix A has m elements in each of the row and n elements in each of the column, then what could be the order? Okay. Harini says n cross m. Naseer says m cross n. Yeah, Sana is also there. Okay, fine. Sana, yes. Ananya says m cross n. Sana again says m cross n. Let us try to understand. Now listen. See, alarms you see. A is there. Let us try to write down in matrix form. m elements should be there in which row, each row. See this m elements. No, suppose I got first element, then second element, third element. Like that, I have got m element and n element in column. So 1, 2, 3, and up to what n. Correct? Don't forget, order of the matrix is given by row cross column. So be careful. See this matrix. After I have written, see they said m elements in row. So in the first I wrote 1, 2, 3 up to m. Like that I can have m elements in each of the row. Coming to column, they said n elements. So you can see 1, 2, 3 up to what n. So now when I'm going to write the order here below this matrix, I have to count rows and columns. Number of rows and columns. You can see how many rows? 1, 2, 3 up to n. Number of row is n. How many columns? 1, 2, 3 up to m. Number of column is m. That's what I'm saying. Try to write and understand, then thinking orally. I understand what you thought. No, row is mentioned, so surely number of element will be m. Column is mentioned, therefore number of column will be n. I hope now this is clear. Okay, so answer is what? N cross m. That is there in option C. I'm not giving the option because there you can say. Kindly comment, is this clear? Those who have answered, kindly comment in the chat box. Is it clear why it is not m by n? It is n cross m. Yes. Yeah, Naseer says clear. Yes, Ananya, Sana, is it clear? Okay, good. Now moving on to question number 3. Question number 3 says, if the order of A is 4 by 3, so we have got a matrix A whose order is 4 by 3, and the order of the matrix B is 4 cross 5, then they are saying the order of A transpose into B whole transpose they want. Don't forget, whenever we take transpose, order will exchange. Mean to say, since I've got A transpose here, what will be the order of A transpose? Number of rows and column will get exchanged. 4 cross 3 will become 3 cross 4. So let us write it here. So this I will write bit bigger. A transpose order is 3 cross 4. Listen carefully now. B order is 4 cross 5. Let us recall the concept. There is no sign between the matrix, nothing but it is matrix multiplication. For matrix multiplication, when do we say matrix multiplication is defined? Number of column of the first matrix should be equal to number of row of the second matrix. Only then we say multiplication exists. So as you can see, first matrix is A transpose, its number of column is 4, and for second matrix B, number of row is same. So matrix multiplication exists. After multiplying this matrix, let us say that I get a matrix C, and that order should be number of row of the first matrix and number of column of the second matrix, nothing but 3 cross 5. Don't forget we have a transpose. Transpose will change the order. So row will change to column and column will change to row. So 3 cross 5 will become 5 cross 3. Therefore, order of this matrix should be 5 cross 3. And 5 cross 3 is there in option D. Kindly comment. Any doubt you have? Yes. Naseer has sent the answer 5 cross 3. Okay, good. Fine. Now, let I give you the next question. Question number 4. I would like you to comment on this. Question number 4 is, if a matrix has 8 elements, how many elements? 8 elements. Then total number of possible different order matrices. I want how many different possible matrices order can we have? Option A 8, option B 6, option C 4, and option D 2. How many different possible matrices we can have? Okay, think of the solution and work out. Till then I will erase this side. Okay, I hope once it has been shown. Yeah, no need to worry, no, to copy the things. Anyway, as soon it is live is done within 15 minutes, it will initiate itself and it will be there in the live session itself. So you are aware, no, than me. You people are well aware about the technology. Okay, fine. Let us see how many of them have sent the answer. So coming to question number 4, which option is correct? Oh, Tukaram Patil, Harini, Ananya, Manikandan, Naseer, Sana, and Vivek Rathod all are saying 4. Let us try to check. So, see, as soon we have got the number of element, don't forget, as soon I know the order, if I multiply the order m into n, that will give number of elements. So let us find the factor of this. So start with the factor 1 into 8, then 2 into 4. Means nothing but just taking the listing of the factors of 8. Then 4 into 2, then what? 8 into 1. So this will say 1 cross 8, 2 cross 4, 4 cross 2, and 8 cross 1. And I hope you understand that 1 cross 8 means having 1 row and 8 columns, and 8 cross 1 means having 8 rows and 1 column. So these two matrices are different. Similarly, these two matrices are different, but number of elements are what? Same. So coming to question number 4, which option? So all are saying 4. Yes, option C is correct. You are right. Absolutely correct. Now, question number 5 on the same is assignment. Now, moving on to question number 6. Listen carefully. Question number 6 says, for any square matrix, A is equal to Aij, where Aij is equal to 0, when I is not equal to J, then what is matrix A? I will read the options for you. Unit matrix, then scalar matrix. C option is diagonal matrix, and lastly row matrix. Come on, think. They said in the question for any square matrix. So for square matrix means what? Number of rows m should be equal to number of column n. So which option will be correct? Okay. Tukaram says diagonal matrix. Halini says option C. Okay, diagonal matrix. Sana also diagonal matrix. Yes, good response. So this is talking about types of matrices. So coming to the option, they said whenever, first let's come to the question, whenever I is not equal to J, it is 0. Nothing but they're talking about non-diagonal to be 0. So if I just take a matrix of order 3 cross 3, so it means they are saying that except the diagonal element where the location of A11, A22, and A33, remaining all elements are what? 0. This is an example, or this is the definition of, in fact, diagonal matrix. Therefore, option C is correct. Now, one question: what change should be done to the question so that it becomes a scalar matrix? What additional condition should be specified that it should become a scalar matrix? Let us see who will send. What additional condition? Till then, I'll write the next question. My question is, what is the additional condition to be incorporated to be B to be the option? Option B to be the option. Till then, right? Next question, number 11. For this option is required, only then we can think of answering. Till then we can think of that condition. Fine, let us see what you have commented. What is the additional condition? Diagonal element should be same. Okay, okay. Harini says Aij is equal to K for all I is equal to J. Yes, right. Similarly, Sana, yes. Sana has went with the particular case the way I've given. Yes, fine. Okay, yes, good, good. And now, similarly, I think for identity matrix that K, whatever has been said, Aij is equal to K or diagonal element should be equal, we have to say it should be equal to 1. Now, let us move on to this question. Kindly stop and listen. Question says, if A is a matrix of order m by n and B is a matrix of order n by n, then which of this is defined? So now we are having again no condition for matrix multiplication. See, coming to all the options, see, we have A into B. Let's go one by one. First, A into B and B into A to be defined as step. Coming to A into B, what is the order of A? M by N. What is the order of B? N by N. So as we know that number of column of the first matrix and number of row of the second matrix should be defined, means they should be equal, I mean to say. Only then A into B is defined. Yes, A into B is defined, no problem. Now check B into A. Coming to matrix B into A, order of B is N by N and order of A is M by N. As you can see here, number of column of the first matrix and number of row of the second matrix are unequal. Therefore, this is not defined. So option A ruled out because AB is defined but B is not defined. Now here AB is there. Here also option B and option D. AB is there. We have checked for A square. What's the meaning of A square? A square means multiplying the matrix A twice. Now again, right, A into A. What is A order? M by N. And again here also M by N. N is not equal to M. Therefore again A square also not defined. Don't forget, in fact, A power N is defined only for which matrix? Square matrix. Is defined for which matrix? Only for square matrix. Don't forget that. A power N, A cube, A power 3, all that. Now option B also out. Similarly, option C without working, we can say out because A square is out. Now B square. Come on. No need to check B square, as I just commented here. A power N is defined only for which matrix? Square matrix. B is a square matrix. As you can see, number of rows and columns are the same. So option C is correct. A into B already we checked. It is defined here. So option B is correct. I hope this is clear. Oh, good. Students are answering. And kindly, please, please mention the question number if you're giving option A, B, C. Yeah. So Tukaram Patil, Harini, and Naseer has said option D. Yes, you're right. I hope Vivek Rathod, is it clear why option C is ruled out better? Kindly comment. Your comment is very important for me because no, I'm not seeing your face, your no expression. Are you clear or not? I have to completely depend on your comments. Okay, I'm not able to see you, but you are able to see me. हम आपको नहीं देख सकते, but surely you can see me. Now moving on to question number 12. I will read the question. You are going to answer this. The question says, 12th question. The number of all possible matrices of order 3 by 3 with each entry 0 or 1. Either the entry is 0 or 1. How many such matrices possible? Send the answer in the chat box. For this, I'm not giving any option. Okay, I know this is clear. Yeah. Even in CET also from matrices will get minimum 3 question, determinant 3 to 4 question, nothing but from matrices determinant minimum 6 question we can easily get. Our target is also that 512, all are saying 512, let's check. See, this is actually the concept of permutation. Since the order is 3 cross 3, number of elements will be 9. So we'll be having 9 box. Nothing but in 9 places I have to fit either 0 or 1. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So here, any one of the two. Which are those? 0 or 1. So 2 elements. Similarly, here 2, here 2, here 2, here 2, here 2. So how many? 1, 2, 3, 4, 5, 6, 7, 8, 9. So by fundamental principle of counting, we have to multiply them. So 2 power 9, which is 512. You are absolutely correct. 512 is there in option 12th question. No, option D. Again, I'm repeating. If you are directly commenting without the option, no need to specify the question number. It's understood. Okay. Now moving on to question number 17. If A and B are two matrices such that A plus B is equal to 7025 and A minus B is equal to 3003, you have to find matrix A. For this, I'll do one thing. I'll give the options for you because typing this will be difficult. So the options are, or if not, I'll just wait for 30 seconds. You'll be ready with the answer. Till then, I write the next question. Then you can match and just comment whether you have got correct or not. Okay. If not, no, solve along with me. You also solve. Surely B minus B will get cancelled. A plus A will be 2A. Then here, how are you going to add two matrices? Corresponding element, correct? So 7 plus 3 will be 10. 0 plus 0 will be 0. 2 plus 0 is 2. 5 plus 3 is 8. So divide by 2. So I'll get A is equal. Why divide by 2? I want only A. I have got 2 into A. So to remove this 2, divide by 2. So we are going to have 2 by 2 is 1. 1 into A is A. Then 10 by 2 will be 5. 0 by 2 will be 0. 2 by 2 will be 1. 8 by 2 will be 4. So 5, 0, 4, 1. That is in option D. Option D. Okay, before proceeding, any doubts? Kindly comment. Any doubts before proceeding? For a while. Yes, I will take a chip. Okay, good. Good. Fine, now let us proceed. Moving on to the next problem. Good to hear. Means good to know. There's no doubt. Moving on to question number 18. I will read the question. Listen carefully. Question number 18. If X is a matrix of order 2 by n. See, even you also know, as soon you come to know, don't write in a formal way. Just write on below the matrix, whatever the order they are saying. 2 by n is the matrix X order. And Z is a matrix of order 2 cross P. Usually I Z like this. When I write Z like this, now I have a doubt always whether the student is understanding as 2 or Z. So to avoid confusion for my sake, I let us Z like this. Okay. Then if n is equal to P, then they're asking what could be the order of the matrix 7x minus 5z. See, simultaneously we are covering the concept along with the problem. Here you can see the scalar multiple. And here subtraction is also there. Don't forget, whenever we have got any two matrices, whether you add, subtract, or you go for scalar multiplication, order will not change. And how to add two matrices? What's the condition for addition? Rows of two matrices and column of both the matrices should be same. Nothing but they should be equal matrices. Number of rows of both the matrices should be equal, and number of column of both the matrices should be equal. For example, if I say that I've got a matrix of order m cross n, then the other matrix order is a p cross q. Then for addition and subtraction, m should be equal to p and n should be equal to q. Correct now? And after you add whatever the matrix you will get either, as soon as m cross n, it's also what p cross q, because both are what same. Same thing for scalar multiplication also. Now come here. X is a matrix of order 2 by n and Z is a matrix of order 2 cross P. When I multiply a scalar, 7 is a scalar, order will remain same. 5 is also a scalar, order will remain same. Since I have got subtraction, n number of column is equal to number of column of the second matrix. N should be equal to P. Yeah, they are saying that's what. So it means I'll get some matrix that is supposed to L. And this matrix L should be of order 2 cross n or 2 cross P. So in the option either you should have a 2 cross n or 2 cross P. Don't forget n is equal to P mentioned in the question. So this is there. 2 cross n is there in the option. That is option blue. Is it clear, my dear students? Kindly comment. Oh, fine. Naseer, then Tukaram and Harini have mentioned. Good. So your preparation is going good. Okay, moving on to next. But I just okay, fine. I'm just making sure that I am not in between the solution. If some students are going to surely see the recorded live session. Okay, let us proceed. Just give me a minute, okay? Yeah, am I audible? Sorry for a small break. Moving on to question number 19. Okay, 19. I will be giving an assignment. One assertion reason type question I have taken similar to this. That time we will discuss. After that, you can take this as an assignment. As I said previously, also that I am not changing the order, not the numbering of the questions. I have tried to make sure it remains the same. And then we have question number 20. See, question number 20, I will just write the data and then it will be assignment. Here, I want to comment one thing. See this question. A is given and matrix B is given. Now we read the option. First, listen the option. If matrix A and B is given, then option A into B and B into A both exist. Option B, A into B exists but not BA. Option C, B into A exists but not AB. Option D, both A into B and B into A does not exist. I only want from you that you are not going to multiply and check. You are just going to see what's the order of this? 2 rows and how many columns? 1, 2, 3. So 3 columns. This is 1, 2, 3. So 3 rows and how many columns? 1, 2. 2 columns. Correct? No. Now from here, the way we did one problem, no, A into B, B into A square, B square exists or not. Same way you're going to go ahead. So this will be assignment. Okay. I hope this is clear. Kindly comment. Can you go for the next? So moving on to, yes, good. Thank you for clarification. Moving on to question number 22. This question number 22, listen carefully, and as soon the question is completed, then you can comment the options. Okay. It's a statement. All options contain statement. Question number 22 says, if A and B are two matrices such that A plus B and A into B are defined, both defined, then option. Okay, we do one thing. I'll not say the option. Come on, they are not given how many, what's the order, so you have to choose in general M cross N and P cross Q. And for this also, then apply the condition of addition and multiplication and let me know in your comment what should be the things there. Nothing but what should be the condition for rows and columns. Let us see. Let us see how many will comment. Till then, I let 24th question. For a suitable matrix of A and B, we have to give what is false statement. By the time I write the options for this, first one is A into B whole transpose is, oh, this is actually B into A whole transpose is A transpose into B transpose. Second option is A transpose the whole transpose is A. Third option is A minus B the whole transpose is B transpose minus A transpose. Option D is A plus B the whole transpose is equal to A transpose plus B transpose. Okay, let's see the comments. Harini says A and B have equal number of rows and columns. Sana says same number of rows and columns. MN should be the same. Okay, now let us try to solve them. Stop and listen. See, they said I want the restriction on the order, nothing but number of rows and columns, such that A plus B and A into B both should be defined. Let us say that for a while order of matrix A is M by N. Okay, I'll write it bit here, bit bigger. Order of A is M by N. Order of B is what? P cross Q. If at all addition is defined, we know that number of rows should be same, nothing but M should be equal to N, and number of columns should be equal, nothing but N is equal to Q, nothing but it should be equal matrices. Now coming to product, so let us write a bit bigger. M, I mean, A is M cross N, and B is P cross Q. So if at all matrix multiplication should be defined, number of column of the first matrix and number of row of the second matrix should be same, nothing but N should be, number of column of the first matrix and number of row of the second matrix should be same, nothing but N should be equal to P. So if you see here, N is equal to P, but N is what? Q. And what is N? N is also M. Nothing but what? See carefully here. If I just come back to matrix A, which is M by N, M by N. But M by N, no. M and N both are equal, nothing but M by M. And what is B? P cross Q. But what is P and Q? That's also what? M by M. Nothing but it should be a square matrix. Number of rows and columns are equal when you're saying what's the meaning of that? It should be a square matrix. I hope this is clear. Thank you, Rafi. So here it should be. I'll read the options now. Option A and B are matrices not necessarily of same order. That is completely rejected. It should be of same order. Option B, A and B are square matrices of the same order. So just saying square matrix is not sufficient. It is not only square matrix, even the order should be same. What's the difference between just square matrix and square matrix order should be same? This can be M cross M, this can be N cross N. So both are square matrix, but both are not having the same rows and same columns. This matrix and this matrix will have different. If I have different alphabet here, like N cross N. So option B is correct, saying that not only square matrix, the order should be also same. Option C says number of columns of A, number of rows of B. No, that should be, need not be, as you can see here. And option D is also symmetric matrix. They are saying they have never given any indication about that. Now come to 24th. This is what I say in regular class, that your properties are so important to be remembered. Now this is completely depending on the properties. Let us see who have answered this. If I know the property, I can surely get this. Come on, I'm waiting. Till then, I will write the next question. (25th) will be assignment. Later, I will be discussing symmetric. That time, it will be. Also, I'll do one thing. I'll take this one now itself. Let you have the continuity. A is equal to 3xy 0. A is equal to A transpose. Then what is the x value? Let us see how many of you have commented. Yes. Halini says option C. Naseer says option C. Now let us try to comment on this. See carefully. They are asking which of the following statement is false. Coming to false, we have to check on. Now see, whenever we take transpose as well as inverse here, the order of the matrix will get exchanged. Here B is the first matrix and A is second matrix. Recall we have one property. What? A into B whole transpose. Is this color visible? Same as B transpose into A transpose. So as soon we are going to A into B whole transpose equal to B transpose into A transpose. So as soon we take transpose, the order will get exchanged. Now since A is first matrix, B second matrix. Sorry, second and first. Now here B is first matrix, A is second matrix, second and first. This is correct, but I want false. This also we know double transpose if we take, we'll get back A. But coming to this, if we take transpose, the order will not change for subtraction nor for addition. So option C is incorrect. Option C is incorrect. Sana is saying something. Sir, I will be getting back to this video. Thank you for your. Oh, okay, it will be helpful. Okay, okay. Fine, Sana. Okay, coming to 25th question. If A is equal to 3x y0 and A is equal to A transpose, then what is X value? See, many students will be operating this. Nothing but they'll write matrix A is equal to transpose, then they'll equal. No, no, no. Not required. If you are perfect with the concept, just by seeing this, is known that what is A, whenever a matrix, square matrix, you can see, is equal to its transpose, this is which matrix? This is going to be which matrix? First of all, square matrix, obviously. And it is symmetric matrix. Symmetric square matrix have just been a bit more particular. Now, for symmetric matrix, this is our diagonal element, correct? No? The corresponding element should be same. What? The corresponding element should be same. So x is equal to y. So they ask what is x value? X is equal to what? Y itself. Yes, Naseer and Harini, all right. So x is equal to y is there in which option for question number 25? It is in option C. Okay. Now let I give you the next question. I'm going to read the question for you. This is a statement question again on concept. Okay, I will read and I will write the data of each option. You have to comment after I complete the option which option is our correct one. 26th question is which one of the following is not true? Okay, I have to point that option which is what not true. In this first option is a matrix, a symmetric matrix. A is a symmetric matrix. A is a symmetric matrix if A transpose is equal to A. First option is this. Second option, for a skew symmetric matrix, A transpose is equal to minus A. Then the third option, for any square matrix A with real entries, A plus A transpose is a skew symmetric matrix. And A minus A transpose is symmetric matrix. And option D, every square matrix can be expressed as the sum of a symmetric and a skew symmetric matrix. Coming to option D, we are already aware of that. 3 marker important questions we are getting now. That every square matrix is expressed as sum of symmetric. Symmetric will be A plus A transpose and skew symmetric will be A minus A transpose, and you give a multiple half here. Reason, if I simplify this, A transpose and minus A transpose get cancelled. A plus A will be 2A. If I don't write half, I cannot divide by 2 and I will not get back what this matrix A, due to which half is given here. So option D is surely correct because of our 3 marker important question. And this doesn't for symmetric, this is for skew symmetric. But coming to option C, this is actually symmetric and this is actually skew symmetric. So option D is incorrect. So they want incorrect one. Option C is incorrect. I hope the same thing you have answered. Let us see the chat box. What you have answered for a while. Yes, option C is incorrect. So it's been answered by Naseer, Manikandan, followed by Harini. Yes. Now let us move on to the next problem. Okay, so moving on to the next question. Yes, question number 27 says the matrix given here 0, 5, 7 minus 5, 0, 11, 7 minus 11, 0 is, I read the option, diagonal matrix option A, Option B, scalar matrix. Option C, skew symmetric matrix. Option D, symmetric matrix. Yes, I would like to see what's your comment. Which matrix is this? So Halini says skew symmetric. What about rest? Okay, fine. I think let a comment. Only Harini has sent the answer. Stop and listen. See, for skew symmetric matrix, the definition is A transpose is equal to minus A for skew symmetric matrix. Now I comment something in this. So if I say matrix A is given as Aij m by n, because a square matrix m by n, so A transpose will be matrix A Ji, again it will be m by m. Now here it is actually minus Aj should be equal to, I repeat, A transpose is less of this, then minus. Now it is Aij. This is I here. Now what's the meaning from this, sir? If you see that index are different, so whatever the index we have got, the element should be same, but sign should be opposite. That's what you can see here. See, 5 minus 5. What's the location of this? A, first row, second column, A1, 2. What's the location of this, sir? Second to first column, nothing but A2, 1. So element, you can see A1 to A2, 1. That's what Aij and Aji elements are same, but sign should be opposite. So that's what, and this minus is given so that minus into this minus will be what? Plus, only then they are equal. Okay, this element sign and this element sign will be opposite. To make it equal, this negative is multiplied to that element so that the sign will be ultimately same. So here you can see here, this location what? First row and which column? Third column, A1, 3. This you can see here, corresponding element. So A3, 1. Similarly, you see this second row and third column. So A2, 3. And this is third row, second column, A3, 2. So ultimately, you can think this diagonal element that I mark in other color, this diagonal element that is 0, 0, 0. We can think as a mirror, and these are the element reflection, but signs will be opposite. Now here, if I just say I is equal to J, just see, I'm going to talk about diagonal elements. Diagonal elements. As soon as I take I is equal to J. So here, this will become Aii is equal to minus of Aii. Transpose this. So Aii plus Aii is equal to 0. 2 times of Aii is equal to 0. Cross multiply 2. Aii is equal to 0. So what I'm trying to comment here is, let us suppose that this particular element or this, any one of the diagonal element is, for example, I suppose this in place of 0 is 5 or some other number. You may think that this number I have taken. Some other number is 10. 10. What do you think? Come on, comment. If this element is 10 or this, is it still skew symmetric? That's my question. And for that reason, I did something here. Some concept I recalled. Is it still skew symmetric? Manikandan says no. What about rest? Hani also says not skew symmetric. Yes, both of you are right. Naseer says yes, no, yes. As soon as one of the diagonal element is non-zero, then it's not a skew symmetric. As you can see, for skew symmetric, when you talk about diagonal elements, it's always what? 0. Very good. Now moving on to the next question. Let us see how many can answer. Question number 28 is, if A is a symmetric as well as skew symmetric matrix, then the matrix A should be what? It is both symmetric and skew symmetric. Option A, diagonal matrix. Option B, null matrix. Option C, unit matrix. Option D, triangular matrix. What do you say? It is both symmetric and skew symmetric matrix. Symmetric and skew symmetric. Halini and Manikandan says it is null matrix. Yes, it is a null matrix. See, let us try to give the explanation also. See, for symmetric matrix, A transpose should be equal to A for symmetric. For skew symmetric matrix, A transpose should be equal to minus A. Now, if I take a matrix A to be Aij, I repeat, matrix A is what? Aij. Then you see A transpose will be Aji. This is Aij. And for this, A transpose what? Aji is equal to minus matrix A what? Aij. Now, since it is both symmetric and skew symmetric, see from equation number 1, Aij is what? Aji. So in place of Aij, I have got Aji. I can substitute here. Aji is what? A. Okay, I'll go from here to here. Fine. What is Aji? Aij. So in place of this, Aij minus Aij. Transpose this. Aij plus Aij is equal to 0. Since signs are same, we can add 2 times of Aij is equal to 0. Cross multiply. Aij is equal to 0. Nothing but each and every element should be what? Having 0. Each and every element are 0. Therefore, it's what? The null matrix. So I thought I'll give the explanation how it is so. Fine. So which option is this? Option W. Null matrix. Other name is zero matrix as well. Now moving on to question number 29. See, one thing you should understand before I go ahead for the next problem, whether it is symmetric matrix or skew symmetric matrix, see one thing very carefully. See, as soon as I talk about symmetric matrix, A transpose is equal to A. As soon as I talk about skew symmetric matrix, A transpose is equal to minus A. I mean to say whether it is symmetric or skew symmetric, transpose is mandatory. If I get plus A, it is symmetric. If I get minus A, it is skew symmetric. So having this information, let us move on to question number 29. Question number 29 says, if A and B are symmetric matrices of the same order, then what will be AB minus BA? Yes, is it symmetric? Option A symmetric, option B skew symmetric, I repeat, option A symmetric, option B skew symmetric, option C null matrix, and option D is unit matrix. Let us solve this. Let us solve this. Listen carefully. Since the discussion is on symmetric and skew symmetric, and in the question they said A and B are symmetric matrix. Since they said A and B are symmetric matrix, A transpose should be equal to A and B transpose should be equal to B. Let us assume the given matrix to be some matrix C. Now I am going to take transpose on both the sides. So C transpose is equal to A into B minus B into A whole transpose. How we got this? By taking transpose on both the sides. Now recall the property. A into B we can take as one matrix. After multiplication we got one matrix. B into A we can think as one more matrix after multiplication. Okay. So we know that one property that A minus B whole transpose is A transpose minus B transpose. Okay. So it means transpose will not change the order for subtraction as well as addition. So this transpose can be taken for AB separately and BA separately. So AB the whole transpose minus BA the whole transpose. After this, we also know that what is A into B whole transpose? The order will change. B transpose into A transpose. So this will become B transpose into A transpose minus B into A whole transpose. This will now. This is the first matrix, the second matrix. Order will change. So get A transpose into B transpose. In the question, they have said A and B are symmetric. So from this data, equation number 1 I can take B transpose is B and A transpose A. So I can just substitute here B here, then A, then minus A, then B. Now if you see this matrix and what is there here, that I'll take as equation number 2. See carefully, are they same? Here BA sign is negative, but here it is positive. Here AB sign is positive, but here it is what? Negative. So if I take minus common here, minus into minus is plus AB, minus into plus will be minus BA. Now from here, this entire thing is nothing but equation number 2 exactly matching. So it is C with minus sign. So left hand is what C transpose. So what we got, C transpose is equal to C. This implies C is equal to this matrix AB minus BA is skew symmetric. Skew symmetric matrix. I hope this is clear. So which option it is? Yes. This option for question number 29, it is option B. Now I have one question to you all. Before proceeding, any doubts? Okay, Vivek, Naseer says skew symmetric. Fine. It is. Now one question to you all. Question is, let us suppose that here I give you plus. Let us write it here. What same condition? Okay. What will be AB plus BA matrix? AB plus BA, B into A. What will be this matrix? Is it symmetric or skew symmetric? Till then, erase the board. Think about this. Let me know your answer. I hope the things are very clear. You are able to understand. Should I be going a bit slow or the speed is fine? Kindly comment about this. Is the flow fine? Okay, Naseer says symmetric. Vivek says, okay, this is I think for last question. You have answered. What about remaining? Harini says it will be symmetric matrix, sir. Okay. Yes, you are right. It will be symmetric because you can see yourself now. AB plus BA. If I give you a plus, here also plus. No, if I give you a plus here, then everywhere will be plus, 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 plus. There's nothing to take minus common out. Here you get plus. And again, you will write AB. And under addition, matrix is commutative. AB plus BA is same as BA plus AB. So you can rewrite, and again, it will be same as the given. So it will be symmetric. Yes, this will be symmetric matrix. Now let us move on to next problem. Question number 30. I want you to answer this. See carefully. If A is equal to 2, 3, 4, x minus 2, minus 2, minus 1, x minus 2, minus 1, minus 5 is a symmetric matrix. If this is a symmetric matrix, then you have to say me what is the value of x. What is the value of x? Okay. Let us move on to 33. Options I will write. Then I will say you the question. I will dictate the question. Okay. This is option C is A into B is 0. Let us see what have you commented. So Harini, Ananya, and Naseer says it is 6. It is 6. Oh, okay. I have written question wrong here. This is 3. This is 3. Okay. Yeah. No, it again, right? A transpose is equal to A. As we know, for symmetric matrix. Yeah, you are right, Harini. I have changed the question. Thank you for your comment. So you see, as you can see that this is our diagonal elements. So this corresponding element should be same. Correct? So x minus 3 should be equal to 3. So transpose x is equal to 6. No, sir, I want to equate this 2. Then you can equate x minus 2 is equal to 4. Then x is equal to 5. Okay. Now one comment from your end I want. Let us suppose, no, I had 2 no here. Forever, let us suppose I had 2 only. Then what is x value? Sometimes when we conduct some mistake, no. Let us use that mistake to understand one more thing. Come on. Let us suppose that whatever the error I did in the question, but question is given like this, then what is the value of x? What is the value of x? Let us see what you're answering. Okay. Money says it should be 5. Then Harini says value of x does not exist. Value of value of x does not exist. Yes, see carefully. If we are getting two different values, oh sorry. After transpose is 6, no. Oh yeah, you're right. X is equal to 6 is the correct answer. Okay. Coming to this one, x minus 2 is equal to 3. If I equate, if this is given, let us write again. In place of, I'm reframing the question. If this is given, so here I have taken as 2. Now you see, if you equate this, we get x minus 2 equal to 4. And if you equate this x minus 2, I mean to say this x minus 2 is equal to 4. Correct now? And sorry. X minus 2 is equal to 3. Yes, I hope now it's correct. Fine. Corresponding element I should equate. Now solve for x. X is equal to 5 I'll get. And here I get x is equal to 6. So this matrix will not be a symmetric. This will not be a symmetric. Why, sir? Come on, put yourself. If I put x is equal to 5 here, see the matrix now. 2 as it is. X value is now 5. 5 minus 2, 3. 5 minus 2, 3. 3 as it is. Then minus 2, minus 1. Then 4, minus 1, minus 5. See carefully. This is the diagonal element. Corresponding element 3 and 3 same, but 3 is not equal to 4. So, and similarly, when I put x equal to 6, then this will be 6 minus 2 will be 4. And 6 minus 2 will be 4. 4 and 4, these two are same, but this will be not equal. The given matrix is not symmetric, and hence x value cannot be determined. So option should be does not exist for x value, or the comment can be the given matrix is not symmetric, hence values of x cannot be determined. I hope this point is clear. Kindly comment. Yes, we can't have two values because each of the value will not give us the symmetric matrix. It will be not symmetric matrix. Okay, fine. Come on. Question number 33. Is it clear? First comment, please. Is this clear? Any doubts? Okay, Mani says clear. Okay, this is also clear. Fine. Now I will read question number 33. And you're going to say the option. Matrices A and B will have inverse of each other only if. Which option is correct? They will have inverse of each other. Then which option is correct? This is purely definition of what? Invertible matrix. Invertible matrix. Last concept in chapter matrices. Okay, Vivek's okay, this is clear, fine. Harini says option D. Naseer also option D. Vivek also says option D. Yes, you are right. If at all sorry, if at all a matrix have inverse, recall the definition of a matrix to be invertible. A square matrix A is said to be invertible if there exists a matrix B such that A into B is equal to B into A is equal to identity matrix, where B is inverse of A and A is also inverse of B, and we denote B as A power minus 1, where A power minus not equal to 1 by A. This represents inverse matrix, and here both are inverse of each other. This is there in option D. So option D is correct. So my also keen thing here is you should be aware of concepts, not just the problems. In fact, even problem depends on what concept only. No, without concept, what we are going to do? How many problems are we going to memorize? Mug up. Concept clear. Problems are you can solve. Otherwise, problem will be a still more big problem without concept. Now moving on to question number 35. Let us see how many can answer. If ABCD is a skew symmetric matrix, which matrix? Skew symmetric matrix. Then you have to comment what is the value of A plus B plus C plus D. No options given from my end. Comment. This is question number 34. Okay. 35. I will give a statement problem it is. So Halini and Naseer says it is 0. What about rest? What about rest? And then he also says 0. Fine. Let us move on to this solution. Since they said skew symmetric matrix, diagonal element should be always 0. So A is equal to 0, B is equal to 0. Coming to non-diagonal, C should be negative of B. And if I transpose this, C plus D should be equal to 0. So now substitute here, A value 0. B plus C or C plus B, both are what? Same, so it is 0. Then D is also 0. So 0 plus 0 plus is what? 0. Yes, you are right. And that is there in option. Question number 34, option C is correct. Now I'm going to go for assertion reason type question. Before we go ahead for assertion reason type question, first understand the importance of this type of question. Listen carefully. In assertion reason type question, we will be having two statements. Statement 1, statement 2. Now, if any one of the statement is false or both are false, no problem for the student. Problem for the student is if both the statements are true, statement 1 and statement 2 both are true, then there will be two confused option for the student. Options will be this. One of the option will be statement 1 is true, statement 2 is true, and statement 2 is correct explanation for statement 1. What? Statement 2 is a correct explanation for statement 1. Whereas one more option will be statement 1 is true, statement 2 is true, and statement 2 is not a correct explanation for statement 1. Not a correct explanation. So as soon as student get both the statement to be true, now the confusion is it a correct explanation or no? So simple logic. While solving statement number 1, if you are taking the help or assistant of statement number 2, if you have used statement number 2 to get the statement number 1, only then it is a statement 2 is a correct explanation for statement 1. Let us suppose you have not taken any help of statement number 2 to get statement number 1, then statement 2 is not a correct explanation for statement number 1. I hope this point is clear. Okay, kindly comment. Is it clear what I just said? Then I'll read out the question for you, and then you can comment about the solution. Kindly comment. Is it clear what I just said? Okay, fine. Now let us move on. Okay, now we'll read the question. Question number 35 says statement number 1. What is the statement number 1? It says if capital A is symmetric as well as Q symmetric matrix, then A is null matrix. If A is what? Symmetric and Q symmetric, and Q symmetric, then it is a null matrix. Statement number 2. A is symmetric matrix if A transpose is equal to A, and A is Q symmetric matrix if A transpose is equal to minus A. Now comment. Before commenting, I will read the option. Listen the option. Statement 1. First, you go to the statement. First, think yourself whether the statement 1 is true, statement 2 is true or false, and then is it correct explanation if in case both are true. I'll just give you some 5 seconds. Think about that. Then I will read the option. Then you have to comment about the option. Okay, already we're getting Naseer is saying both are true. Okay, now I read the option. Option A, statement 1 is true and statement 2 is false. Option B, statement 1 is false and statement 2 is false. Option C, statement 1 is true and statement 2 is true. Statement 2 is not a correct explanation for statement 1. This is option C. Option D, statement 1 is true and statement 2 is true. Statement 2 is a correct explanation for statement 1. Yes. What is the answer? I have read out the options for you. Yes, Naseer says statement 2 is correct for statement 1. Ananya says option D, yes. Option D, yes. Even Harini, yes. You people are right. Good job. Vivek, yes, you are right. Let us move on to the next problem. Moving on to the next problem. Question number 36. Again, it's an assertion reason type question. Statement 1 is this. 0, 1, 0, 1. 1, 1, 0, 0. This is equal to null matrix. Statement number 2. First check statement number 1. Is it true or false? Matrix multiplication you have to do. I hope you have did. Is it done? Okay, now read means I'll write. Yeah, statement number 2 says for the matrices A and B, A into B is equal to 0 matrix, then it is not necessary that that A is 0 matrix or B is 0 matrix. Okay. We know this is one of the important property which we have got, that product of two real numbers 0 means either M should be 0 or N should be 0. But product of two matrices is equal to 0. It need not happen that anyone should be 0, as you can see here. Both this, if I say matrix A, this is matrix B, multiplier row versus column, you will get this matrix. Both are non-zero matrix. To be a 0 matrix, each and every element should be 0. Since here we have got 1, 1, 1, 1, these are non-zero matrices. So even though these matrices are non-zero, product is 0. That's what this is also true after multiplying. And I hope all of you agree that this is also true. And this is a correct explanation for statement number 1. So I will write the correct option. It is in option B. Option blue. Any doubt in this? Kindly comment. Any doubt in this? Yes, Naseer. You are right. Now let us move on to next. Can I this side? Means yeah, then no, and you're not copying. Okay. Now moving on to the next problem. Question number 37 is assignment. Moving on to question number 38. See carefully 38. Means listen carefully, I mean to say. Statement 1 is A is equal to 0, 1, 1, 0. This is an identity matrix. They are saying that this is a what? Identity matrix. Statement 2 says a square matrix A is identity matrix if Aij is equal to 1, if I is equal to j, 0 if I is not equal to j. So, which statement is true? That's what an option they are asking. So, Holly is saying false true. What about rest? A very elementary question they have asked on types of matrix. So, then Naseer also saying same. Okay, so now let us comment. See carefully. For identity matrix, this is of order 2 cross 2. It's not an identity matrix. The identity matrix of order 2 cross 2 is 1, 0, 0, 1. That's what is said here. Diagonal elements are always equal to 1. Non-diagonal elements are 0. I equal to j stand for diagonal elements, which is here A1, 1. This is A1, A2, 2, I mean to say. And this is A1, 2, first or second element. And this is A2, 1. Index are different. When index are different, it is a null matrix. Yes. So statement 1 is true and statement 1 is false and statement 2 is true. So that is there in option. Question number 38. Option Bablu. Now let us move on to question number 40. Question number 40 says assertion. Again, assertion reason type question. Assertion A is the matrix A given by this 0, 2, 3. Okay, this will be assignment. This will be type we have already discussed. This will be assignment. Okay, I have already discussed this. Now see question number 41. Statement 1. Statement 1 is two matrices A of order 2 by 3 and B of order 3 by 2. These are the two matrices. Can be multiplied and their product will be of the order. So after we multiply A into B, I get one product and this product is 2 by 2. This is the statement number 1. Statement number 2. Listen carefully for statement number 2. Then you can comment about statement number 1. Statement number 2 says two matrices can be multiplied if number of columns in the first matrix must be equal to number of rows of the second matrix. First think about statement number 2. Is it true or false? Then comment about this. Then I will read the option. First you think about this. So if at all matrix multiplication exists, number of column of the first matrix A should be equal to number of row of the second matrix B. That is obvious. Only then matrix multiplication exists. Therefore it is true. And that's what you can see, that number of column of the first matrix and row of the second matrix are equal. After I multiply, the order should be number of row of the first matrix and number of column of the second matrix. That's what they have given. This is also true. And surely I have used this fact to get the answer. Therefore, it is a correct explanation as well. that is there for question number 41. That is there in option B. Okay. Question number 46 will be assignment. Assignments are mandatory. Without assignment, there is no success. Now let's move on to question number 49. Question number 49 says, if capital A is a matrix of order m by n. So A is a matrix of order m by n. Okay. B is a matrix. Okay, they are not mentioning anything about B. Just they said B is a matrix such that A into B transpose and B transpose into A. See, in the text they have given here like this. Whether A property or A dash, both stand for transpose only. Correct? No. So I just mentioned as A dash throughout and B dash. Okay. So they are asking if this both are defined, then what will be the order of matrix B? Come on. Send in the chat box without options are given. What could be the order of matrix B? I'm waiting for your answer. Till then, I will erase this side. Let us see what is the answer. Okay, Vivek Rathore, first time attend live session. Yeah, okay, good. This is my 5th live session. Everyone has a first live session. And this is the 4th live session for second PUC. First PUC live session was too good. It went from 7 p.m. till 12 a.m. 5 hours up, at most 5 hours, 4 hours, 45 or 50 minutes. All 14 chapters I took. My MCQ question and fill in the blanks. Saturday, last week Saturday. Not last week, this is Saturday, no? Today Saturday, no, Sunday. Not last week, last week. It was very good. Okay. Fine. Now let us proceed. No one with the answer? Okay, let I comment. Harini says M by N. Manikan says M by N. Now, okay, let us comment. All of you stop and listen. Kindly pay attention. See, let us assume that the matrix B order which we have to find is of order P cross Q. Since B transpose is there, as soon as I find B transpose, this order should get exchanged. So A order is M by N. The B order will be Q cross P. So since matrix multiplication is existing here, number of column of the first matrix and number of row of the second matrix B transpose should be same. So N should be equal to Q. Next, B transpose. So again, it will be from P cross Q, it will be Q cross P, and matrix A is M by N. Now here, again, this matrix multiplication to exist, number of column of the second number of column of the first matrix, I mean to say, I repeat, number of column of the first matrix should be equal to number of row of the second matrix. So P should be equal to M. So therefore, the order of the matrix B, which is P cross Q, we have assumed, it will be, in place of P cross Q, it will be M cross N. Yes, you are right. M cross N. Now, which option is this? Yeah, Vivek, Manikandan, Harini, you are right. Question number 49. Option D. Now, one question to you all. What could be the order of B transpose? What could be the order of B transpose? I would like to know from you all. Harini says N cross M. What about rest? Vivek also says the same thing. Just give me a second. Okay, now we'll read question number 59. I would like to solve rather. Kindly pay attention, listen carefully. I think climate is changing now. It was not so hot. Huh? Question number 50. If A is a square matrix such that A square is equal to identity matrix, then what is A minus I the whole power 3 plus A plus I whole power 3 minus 7A? What is the value of this? Kindly stop and listen. See, this is going with the form A minus B whole cube. So I'll do one thing. In place of solving this, no, this entire, only for this, I will take this A minus B whole cube plus here, then A plus B the whole cube. Let us find this and simplify. Then in place of small a, matrix A, in place of small b, matrix I, we can substitute. A minus B the whole cube formula is A cube minus 3A square B plus 3AB square plus B cube. This is the expression for A minus B the whole cube. Plus, okay, plus A plus B whole cube will be A cube plus 3A square B plus 3AB square plus B cube. Now, since we have to add them, okay, add what is A minus B the whole cube plus A plus B the whole cube. Very clearly, this term gone and forever. Plus minus, this is minus. Sorry, this is minus. Minus there, no. So by the way, plus minus, this is also gone. So A cube plus A cube is 3 times of A cube. 3 plus 3 will be 6 times of AB square. So now I can go for this. What they have given? A minus I the whole cube plus A plus I the whole cube, then minus 7A. Now only for this part, I can use this. So in place of small a, it is capital A. And in place of small b, it is capital I. So put here 3 times of A, sorry, oh yeah, 3 times of A cube, no, A cube, then plus 6A, in place of B, I square, then minus 7A. Now see carefully, A square is A, but I've got A cube. Multiply both the side by A. So A square into A is equal to I into A. What is A square into A cube. Or is I into A? A. Don't forget, whenever you multiply identity matrix with any matrix A, what do you get? A itself. If multiplication is defined. So the value of this will be 3 times of A cube is A. Then when and what is I power n? It's always what? I only. And so this is I. So 6 times of I minus 7A. What is minus 7A plus 3A? It will be minus 4A. Sorry, 4A, no. Yes. Then we are going to have plus 6. A into I is A. I think I got last time as A. Anyway, first we'll complete this. 2A will be the answer. 2A will be the answer, A cube. Oh, wait. I did one mistake here. What is A cube plus A cube? Sorry. I will do the change in red color. What is A cube plus A cube? 2A cube. Correct? That's the one error. So in place of A, we are using capital A. In place of B, capital I. So here 2. So that should be 2 here. Remaining all fine. This should be again 2. Then 2 minus 7 will be minus 5. Minus 5 plus 6 will be plus A. A is the answer. I have changed in red color. Kindly comment. Is this clear? It's not 2A? Yeah. You are commenting. Yes. You are asking about is it not 2A cube? Yes, Harini, you are right. So this is 2A cube. So which option is this for question number 50? We are getting option A. Kindly comment. Have you understood? How should I repeat again the problem? Let me know. Yes, I'm waiting for your comment. Is this clear? Rex is clear. Remaining. Hari says clear. Fine. Let us move on to next. Moving on to the next problem. Question number 50 done. Okay. Question number 52. This all a statement problem. There are three statements here. Listen carefully. This is actually on types of matrix. Okay. Diagonal, scalar, identity. Matrix. Sorry, what's coming out? Let us move on. Question number 52 says, statement 1. Every identity matrix is a scalar matrix. Let us mention that statement, then you decide. Every identity matrix is a scalar matrix. Statement number 2. Every scalar matrix is a diagonal matrix. Statement number 3. Every identity matrix is a diagonal matrix. Fine. Let's see what's your comment. You have to do on the options are they are only talking about which statement is true. Okay. So instead of giving the options, you can just comment which statement is true. Which statement is true. Question number 51, I have not taken. As I said, no. The questions which are different, I'm taking. Okay, wait. Question number 51, no, is already done. The same type we have discussed already. 51 is assignment. Same type we already discussed. Oh, it's a repeated question actually. Yeah. I'm waiting. This will ask your basics of types of matrices knowledge. How good you are. Manikandan says, Naseer and Harini says all the statements are true. Okay, let us try to see one by one. Kindly focus, pay attention. Every identity matrix is a scalar matrix. Let's try to recall definition for all identity, scalar, and diagonal matrix. First is diagonal matrix. What is a diagonal matrix? First of all, what is a diagonal matrix? Coming to diagonal matrix, it is a square matrix in which non-diagonal element should be 0. Just I'm taking two cross example to make it clear. Next comes scalar matrix. What is a scalar matrix? It is a square matrix in which diagonal elements are same. Non-diagonal elements are what? 0. What is identity matrix? Coming to identity matrix, it is again a square matrix in which diagonal elements are always equal to 1 and non-diagonal elements are what? 0. Now from here, one by one comment. See, Actually speaking, scalar and identity matrix, non-diagonal should be always 0, nothing but this is the definition for the diagonal matrix. But here, this is a special case. What I'm saying is both are diagonal matrix. The thing is, both of them have got one more special condition. For scalar matrix, diagonal element should be same and can be equal to any number. But for identity matrix, still more particular case of scalar matrix. What? Diagonal element should be 1. So every scalar and identity matrix are actually, let's comment here. Let's comment here. Every note, we can remember this better. Note number 1. Every scalar and identity matrix are what? Diagonal matrix. I hope all of you agree with this. And every identity matrix is a scalar matrix. Why? For scalar matrix, non-diagonal should be 0 and diagonal element should be same. It can be equal to any number, but for identity should be equal to 1. So every identity matrix is scalar matrix. Now come here. Every identity matrix is scalar matrix. Yes, it's going with this, so it is true. You are right about this statement. Statement 1 is true. Every scalar matrix is a diagonal matrix. Every scalar matrix here is a diagonal matrix. This is also true. And every diagonal matrix is also a scalar matrix. This is also true. Yes, you are right. All the 3 statement is true. And that is there in which option? Now one question I will ask you. Listen carefully. When I first comment this 50-second question is option A. Now my question to you is 0 matrix of same order, nothing but square matrix, 0 matrix is there, no? If it is n by n, then this is which matrix? Diagonal, scalar, identity. Let us see. Who will comment? The question is clear. 0 matrix need not be always square, but if I take square matrix, this will be which matrix? Is it scalar, identity, or diagonal matrix? Till then, next question. Okay, money have there. Okay. Moving on to next question number 52 done. 55. Scalar. Okay. Yes, you are right. And when you are saying scalar matrix, you are also saying it is a diagonal matrix. Why it is scalar matrix? Diagonal elements are always equal to 0. So yes, it is a scalar matrix. And I can also say it is also a diagonal matrix because every scalar is a diagonal matrix. Now coming to question number 55. It can also be considered as a diagonal matrix or as a scalar. It is also being considered as diagonal matrix, as every scalar matrix is a diagonal matrix. Yes, you are right. You are right. Yeah, Varini, Vivek, Naseer, yes, and Ananya. Good job. Good job. People are studying really well. Proud of you all. Now moving on to question number 55. I'll give a property here. The question says if A is a skew symmetric matrix, then A square is a symmetric skew symmetric matrix. Then one more option is null matrix cannot be determined. See, one note you remember. Listen carefully. And this will be very handy as well for competitive examination also. I will give a note here. What is that note? Let us suppose if A is, and I erase that side, space is not sufficient. See, note is, write the note here. Note number 1. If A is, like go group like this at once, in one note, I complete both. Let us suppose A is symmetric matrix. A is symmetric matrix. Then A power n is always symmetric. Even if you talk about not even A power n, even inverse of that also. If I know A inverse formula 1 by determinant of A into adjoint A, that also will be symmetric. Even its transpose also will be symmetrical. Okay. But if A is skew symmetric matrix, second division, skew symmetric matrix, then we will have two division here. What? We will have two division here. Let us write it like this. A power n, if I take, we will have two division. What? N, if it is, this power is n, if it is even. And the same power n if it is odd. If n is even, A power n is symmetric. And if n is odd, A power n is skew symmetric. Remember this result. Now come here. I repeat again. If n is a symmetric matrix, whatever power it is even or odd, no problem. N is a natural number here, no problem. But if we have got A power n is even or odd. If n is even, symmetric. For odd, it is skew symmetric. Now come here. A is skew symmetric, but the power of A is what? 2. 2 is what? Even number. Therefore, again, we got the symmetric matrix because of that concept. Symmetric matrix. I hope this is clear. Kindly comment. Is that clear? Should I repeat or should I explain the reason, or that's enough? Should I explain the reason here, especially even and odd? So question number 55, which option? Option Bablu, symmetric. This is the answer. Okay, clear, fine. Let us move on to next. Moving on to next problem, question number 56. Question number 56. Let us see who will comment this. I will read the question. Listen carefully, okay? Capital A square matrix, a square matrix A in which all elements except at least one element in diagonal are zeros is said to be. I repeat the question. A square matrix in which all elements except at least one element in diagonal or zeros is said to be option A diagonal matrix, option B null matrix, option C unit matrix, option D triangular matrix. Come on, let us see who will comment. Hani says diagonal matrix. Manikandan also says the same. Followed by Vivek. Yes, you are right. Very good. It's a diagonal matrix. You're right. And the answer is option 56. No, option A. Option A. Now moving on to the next question, 57. Question says, which of the following is not possible ordered pair for the matrix with 6 elements? So they are given 6 elements. A matrix has got 6 elements. So now you have to say in the option which ordered pair is not possible. Option A, 2 cross, okay, 2 comma 3 ordered pair from the given. This says number of rows, this is number of columns. Okay. B, 3 comma 2, C, 1 comma 6, D, 3 comma 1. Come on, comment. Which of the following is not be the pair? Which pair will not be ordered for this matrix having 6 elements? Ananya says option D. Manikandan 3 cross 1, nothing but option D. Fine. Harini also option D. Yes, you are right. Option D. Because if at all we want 6 elements, if I multiply the number of rows and columns, don't forget if m cross n is the order of the matrix, then m into n will be number of elements. So 2 into 3, 6, 3 into 2, 6, 1 into 6 is 6. But 3 into 1 is 3. 3 into 1 is what? 3, but not equal to 6. So option D is incorrect. One incorrect only. Yes, you're right. Now we are going to go for the last problem in my chapter matrices. Then we'll take determinants. Question number 58 says if A and B are two symmetric matrices of the same order, so A transpose is equal to A, B transpose is equal to B, because this is a symmetric matrix, then statement number 1, A plus B is symmetric matrix. Symmetric matrix. Statement number 2, A minus B is a symmetric matrix. Statement number 3, AB plus BA is a symmetric matrix. Which of the option is correct? Get the answer till the ink in the marker is getting a bit lighter, I believe. Get the answer. Actually, statement 1 is already true. Statement 3, today in the problem, I just asked a cross question. You got it right. Only have to check statement number 2. Yes, I'm back. So let us see what you have answered. Harini says all the statements are true. What about others? Vivek says question number 58, all are true. Manikala says statement all are true. Let us check. So moving on to see statement number 1. It's two undoubtedly from already one concept we have got. Anyway, I'll just go one by one. Coming to statement number 1, A plus B, if I assume to be matrix C. So if I take transpose here, A plus B, the whole transpose will be A transpose plus B transpose. But here A and B transpose same as A and B. So I got what? C itself back. Here itself, if you see, okay, let's do separately, no problem. Let us avoid confusion. For statement 2, A minus B, I have to consider. I'll take as some matrix D. So if I take transpose here, the whole transpose I'll get A transpose minus B transpose. A transpose A, B transpose B. So we will get A minus B, nothing but back. Yes, this is also symmetric. And this one is already done by us in one of the problem I just asked you. I went for A, B minus B. It was Q symmetric. For plus I asked and you gave the answer, it is symmetric. Yes, you are right. All the three statements are true. Statement 1, statement 2, and statement 3 are true. Yes, you are right. So with this, we have completed all the problems from matrices which I have selected. Question number 58, option A. All are true. Okay. Fine. Now, let us move on to the next chapter, determinants. Come on, what is determinant? Can a determinant value is always positive, negative, or zero? Answer this. Determinant of which matrix you have to take. First answer, determinant should be taken for which matrix? Square matrix or any matrix? Determinant is taken for which matrix? Any matrix, any general matrix, or a square matrix? Yes, Mani is saying it is. My God. Mani is saying it is square matrix. What about rest? Oh, so soon. It is 2 hours, almost 2 hours of live session. Good. So Vivek says, okay, the answer for the previous one, Harini, Ananya, and Manikandan. Yes, you are right. It is only for square matrix. So what is determinant? Let us give the chapter name here. We are dealing with now determinants. Now coming to the chapter determinants. Again, you're dealing with one marker, nothing but both MCQ and fill in the blanks. We are dealing with. Yeah, what is a determinant? We can say it's a function which maps every square matrix to a unique real number. Function we say no, f from A to B. So A is a domain, B is the codomain. So in place of this f, I can have delta symbol, which maps every square matrix M. And as a square matrix, number of row and column should be same to a unique real number R. So every square matrix is being taken here. That is a small evaluate here. And I'm going to get some real number L. And this L is real number. So when I say real number, L can be negative also, positive also, zero also. I have seen many times students, since the determinant of any matrix A is taken as DET of A, or this modulus sign is different from usual modulus of a number. If you have a number, then it is converting negative to positive. But for matrix, it's giving one particular value. It can be negative, positive, or zero. Okay, one question to you all. If A is matrix minus 7, then what will be the determinant of this? Send me in the option in the chat box. Let us see. I'm waiting. Honey says -7. What about rest? Okay, the comment. See, this is a matrix of order what? How many rows we have? One row, and how many column? One column. So 1 cross 1. So determinant of this is -7, nothing but -7 itself. It's not +7. Inside we are taking, just see, it should be actually like this matrix here, then a determinant. So we are talking about what? Determinant of a matrix. So it is the same number, same number. So in short, if I have got any matrix of order 1 cross 1, then determinant of A is the same real number. Whatever present here, same. It will not change negative to positive, now positive to negative. Now it will make it 0. Same it will be. Okay. Fine. I hope this point is clear. Kindly comment. Okay. See, the chapter means determinants. We are going to have some properties. Those properties are the one which is going to give our answer faster. So what I will do, I will try to list out all the properties here. Make sure, make a note. And this property, some of the property, is not there in NCERT text. Okay. So, and I will try to give both. Okay. First one is determinant of k into a, where k is a scalar, will be k power n into determinant of a, where n is order of matrix A. Order of matrix A. Second, determinant of adjoint of A is determinant of A whole power n minus 1. Again, n is the order of the matrix A. Third, determinant of zero matrix, determinant of identity matrix. Let us see who will comment on third. So for this, no, comment as 3. First answer, comma, second answer. Okay, let us see who will comment. I would like to see. Next, fourth one. A inverse formula, we know it is 1 by determinant of A into adjoint of A, where determinant of A is not equal to 0. If determinant of A is not equal to 0, we say non-singular. If it's equal to 0, we say singular matrix. Next, what about, yeah, A into adjoint of A, which is same as adjoint of A into A. This is determinant of A into identity matrix. Sixth point. Yes. Okay, that one I have not seen in this. Let us not give that one which is not there in the questions. I'll do one thing. As and how we go now, we'll list out depending on that. Let you also make a page, as and how we go ahead. Don't try to leave one page or one page sufficient. Leave it empty now on the chapter determinants. As and how we write, we can make it out. One more. Determinant of A inverse is same as determinant of A power minus 1, nothing but 1 by determinant of A. See the advantage of this formula. If they ask you to find determinant of A inverse, first you have to find adjoint A, then divide by determinant of A, then you have to take the answer. Then you have to take determinant. We are saying determinant of A inverse if you want. Find the determinant of the given matrix, take the reciprocal, that will give you inverse determinant. Seventh, determinant of A power n. What's the meaning of this, sir? Multiply A n times and then find the determinant. In place of that, just find the determinant, raise the power n. Here the advantage you see. Just you should find the determinant and just multiply the number which is obtained, those many n times. But here multiply the matrix. Even if I said 2 by 2 matrix, 3 by 3 better. It takes some time, but this will not take much time. Just you have to find what? Determinant and raise the power. Okay. So as and how we'll go ahead with the problem. We will just comment one by one. Now let us see what we have. Ananya, what if it was -7, 9? You are talking about a matrix, Ananya? Are you talking about matrix -7, 9? If this is a matrix A, are you asking what is the determinant of this? I have write the question. Kindly comment. Have you asked for this? Let us suppose you have asked for this question. When you see what is the order of this matrix, 1 row, 2 column, 1 by 2. This is not a which matrix? Square matrix. Since it's not a square matrix, determinant does not exist. Answer should be what? Determinant does not exist. Because for determinant to exist, as I said, it should be a square matrix. I hope this is clear, Ananya. Very good. Any other doubts? This type of involved in the involvement really makes the faculty also to be happy and then go ahead with the class. Good. Fine. So what's the answer for third one? It's not option. I have just reserved properties. I can give the heading as properties. Properties. One more. Determinant of A into B is same as determinant of A into determinant of B. One more we have determinant of A into B into C is same as determinant of A, B, then C. Nothing but we can just see here what it says. Find the determinant of product of matrix A and B. First you have to multiply A and B, then find the determinant. They are saying no, not required. We can use a property that we can find the determinant individually. Since I want product, multiply them. Same thing for product of 3. Not only for 3, n number of matrix. Okay, it will be the same. Okay, so Halini has comment that for third one, determinant of 0 matrix is 0. Determinant of identity is always what? 1. You can just see here. For 0 matrix, all the elements are 0. For example, 2 by 2. Then what is determinant of this? 0, 0, 0, 0. How you do? Plus minus, cross multiply. Yeah, 0 minus 0, nothing but 0. Therefore, determinant of null matrix is what? 0. Coming to identity matrix, again 2 by 2 static, 1, 0, 0, 1. Here it is determinant of I will be 1, 0, 0, 1. So again plus minus 1 into 1, 1 minus 0 into 0, 0. 1 minus 0 is 1. So determinant of I is what? 1. Okay. Fine. Let's proceed as in how we will take the problem. No, we will try to solve them. Okay. One more. See, determinant of a matrix and its transpose both are same. Determinant of a matrix and its transpose both are same. So fine. Now we will go ahead with the problems. Before proceeding, any doubts? Yes, now we'll go ahead with the problem. As I said, kindly make a note of all this. Okay, these are the properties which will make our job easier, faster. Okay, fine. Now the problem from determinants are taken around 42 questions. We'll take one by one. First problem, and this will not take much time because of property, the things will be a bit faster. First problem, if A is equal to K times of matrix B, where A and B are square matrices of order n, then what is determinant of A? They are asking. They are asking what is determinant of A. Since they want determinant of A, we can take determinant on both the sides here. Don't forget K is a scalar here. So by applying the first rule, see, don't see the right hand side, mean to the left hand side. See right hand side. This is product of a number and a matrix. Yeah, product of a number and a matrix. k power n into whatever matrix, the same matrix with the determinant. So here the matrix is B, so determinant of B will get, and k power n. Now, if what is n here? They say square matrix of order n. So k power n. Therefore, determinant of A is k power n into determinant of B, which is the option blue. Is this clear? Is this clear? And I want to comment one more thing, one note. Okay, we'll take as a note. Come on. Evaluate this problem and semi fast. I'll not give you very big numbers, small numbers I will give you. Evaluate this. First is this problem. Second is this problem. I am waiting. Till then, I'll complete this question. Okay, Halini says first one is 0 and second problem is a square. What about rest? Determinant of 2 by 2 and 3 cross 3 have asked. How to do? What is we call? Plus minus plus, correct? So plus into plus here plus 0. 0 into leave this row and this is column. Remaining 0 minus 5, 5, 0. 0 minus 5, 5, 0. Then there was no need to write this. I wrote because to make you understand again recalling. Okay, minus minus is plus 1. Leave this row, first row and second column. So you get 1 minus 5 minus 2 0. 1 minus 5 minus 2 0. Then plus into plus is plus plus 2. Leave the first row and the third column. This first row and third column. 1 0 minus 2 5. 1 0 minus 2 5. Now simplify. 0 and anything is 0. So then why you wrote this? To just recalling the concept. Okay. Then plus minus. 1 into 0, 0. Minus to minus, plus. Plus into minus, minus. 5 2s are 10. Then plus 2 times off. Again, 1 plus minus. 1 5s are 5. Minus minus plus 2 zeros are 0. 5 plus 0, 5. 0 minus 10 is minus 10. Minus plus is minus. So minus 10 plus 10 will be 0. Oh, we got 0 here. Fine. See this plus minus. 0 to 0, 0 square, and equals 0 itself. Minus into minus plus. A into A is A square. Square, we got a perfect square. Now see carefully. Take this for a while. Is it not? This is a square matrix. If I take in the form of a matrix, it's a skew symmetric matrix. This is also a skew symmetric matrix. For skew symmetric matrix, diagonal elements are 0. Yeah, it is. Non-diagonals are same, but signs are opposite. Signs are opposite. So this is of order 3, nothing but odd order. And here the order is 3. So whenever you have a skew symmetric matrix of odd order, the determinant value is always 0. Whereas this is also a skew symmetric matrix, but of even order 2 cross 2, then it will be a perfect square number. Surely it will not be 0. Let us suppose A, both here elements are non-zero, then you get a what? Non-zero perfect square number. Let us suppose it's a 0 matrix. Take a determinant, you'll get here 0 square nothing but ultimately 0 only. So having this knowledge, see this question. As soon as we see this question, we'll think of expanding this. But see carefully, diagonal elements. See carefully. Is it not here? The diagonal elements all are what? Zeros. Whereas non-diagonal elements are same, but signs are opposite. What is this? Skew symmetric matrix. Skew symmetric matrix of what order? How many rows? 1, 2, 3. How many columns? 1, 2, 3. So of order 3, we won't write 3 by 3. It's understood. No, for square matrix, we just say 3. It's understood. Number of rows and columns are what? 3. Since it's a odd order, odd number, the value is what? 0. No need to work out. Direct answer. Is this point clear? Is this point clear? Let us have as a note. What's the note? Determinant of a skew symmetric matrix of, from here to division, odd order. If it is odd order, then it is 0. It means determinant. Okay. And if it is even order, then it means again determinant. It is perfect square number. Perfect square number. Here in place of e, I could have taken some number, summing. So here -7, here 7. Minus plus 7 7 is 49. 0 plus 49 is 49. 49 is a perfect square number of 7. Okay. Is this clear? You can make a note of this. Of this formula, you can make a note. Okay. As I know, I'm going with the problems. That will be handy. Any doubts before proceeding? Any doubts? Only convince is clear, sir. What about rest? Any also is clear? Fine. Okay, let's move on to the next problem. We'll be coming back to this part again in some of the problem. Last second, some problem it is there. So there now I would like you to remember this. And you are going to say the answer. Fatafat, okay. Now let us move on to the next question. Moving on to the next problem. Question number 3. We have to find the value of x. We have to find the value of x if 3x, determinant of 3x x1 is equal to 3, 2, 4, 1. See, many will do like this. They'll think as matrix and they'll equate x is equal to 2, x is equal to 4. No. This is wrong. This is not a matrix. It's a determinant. Only for matrix corresponding element should be same. If this was a matrix question, then the answer is it's not an equal matrix because x equal to 2 and x equal to 4 writing two different values. Correct? No. So now evaluate because the determinant. So 3 ones are 3 minus x into x is x square is equal to 3 ones are 3 minus 4 twos are 8. 3 will get cancelled. Minus x square is equal to minus 8. Negative will get cancelled. X square is equal to 8 or x is equal to plus or minus root 8. 8. Simplify 2 fours are 8. Plus or minus root of 4 into 2. Root of 4 is 2. Root 2. I hope this is clear. And this is there in the option D. Kindly comment any doubt. Is this clear? Moving on, next question. Question number 7. If A is equal to 1, 0, 1, 0, 1, 2, 0, 0, 4, then what is determinant of 3A? See, for this, we can use this property. So this will be 3 power n. N is what? Order of the matrix A. Or order 3. So 3 power 3, determinant of here. Now here I'll give you one formula. Listen carefully. That's what I said. No, you can just list up. So 11th you can make a note. What is that? Determinant of. Let us suppose no, you have got a matrix. Let's say A, B, C. Above the diagonal elements are 0. Below it is not. Similarly, diagonal elements are A, B, C. Below the elements are 0. Above it is not 0. Again, this is also, it can be like this also. Above also 0, below also 0. This is actually, if I take a matrix, no, this we call it triangular matrix. Whenever either above or below all the elements are 0, then we call this triangle matrix. So for all this, the value, see this here, diagonal matrix is there. Above all 0, below all 0. Here also diagonal matrix, diagonal elements, I mean say diagonal elements are there. Above and below all the elements are 0. Here also diagonal elements are there. Only above or 0 here. Here only below or 0. Then the answer is product of the diagonal elements. A into B into C. Product of the diagonal elements. Now come here. Can you see with respect to the diagonal elements 1, 1, 4. These elements are 0. Therefore, determinant of A should be product of the diagonals. So it will be 1 into 4, nothing but 4. So 3 power 3 will be 27 into 4. Right now, 4 sevens are 28. Borrow 2, 4 2s are 8, 9, 10. 108. Answer will be 108. Is this point clear? Kindly comment. Answer is option D. Is this clear? Just give me a minute. Not even a minute. Just 30 seconds. Okay. Fine. Any doubt before we proceed? Can you go ahead? Okay. Moving on to next. Okay. Money says there's no doubt. Okay. Fine. Harini also says no doubt. Fine. Let's move on to the next. So this will be your result number 11. Okay. And which I'm erasing now. You can make note of the formulas, because now as and how we proceed, you can have a note of that. There are some of the formulas which are not there. For example, 6th, 7th is not there, 10th is not there, and this is not there. We have to go beyond the PUC to get the answer faster. Now let us move on to next. Moving on to question number 10. I will read the question for you. I will read the question. Which of the following is correct? Option A. Determinant is a square matrix. Determinant is a square matrix. Option A it is. Option B. You have to identify what correct one. So what do you think? First option I was every. Okay. Determinant is a square matrix. First option was that. Option B. Determinant is a number associated to a matrix. Option C. Determinant is a number associated to a square matrix. Option D. Determinant is just an argument of numbers. Among this, which is true? Which is correct? It is just completely based on the definition. Yes, I am waiting. Option C. Harini says option C. Yes, it is associated to a square matrix. Option C, purely concept based. 11th question. We have to find the adjoint of the square matrix of order 2 cross to 2, 3, 1, 4. 2, 3, 1, 4. So I have to find the adjoint. So coming to adjoint of a matrix. how to find? We have to interchange the diagonal element. So 4 here and 2 here. And then we have to change the sign. I'm using the word change, not interchange. Interchange. Diagonal element, yes, interchange. Interchange elements. Whereas non-diagonal elements, we have to change the sign. Change the sign. So what's the sign of 3? Plus, change to minus. Sign of 1, plus, change to minus. That's it. That's it. So question number 11, option D is correct. Yes. Now moving on to 12th problem. Can we go ahead? Any doubts? Any doubts? No? Okay. Coming to 12th problem. If A is non-singular matrix of order 3, non-singular means determinant of A should not be 0. So non-singular determinant of A should not be equal to 0. Question number 12. If A is a non-singular matrix, then of order 3, then what is adjoint of A determinant? Adjoint of A determinant is determinant of A whole power n minus 1, where n is the order of the matrix. Here they said order is 3, so n is equal to 3. So we will have determinant of A whole power 3 minus 1 will be 2. 3 minus 1 will be 2. That is in option blue. Okay. Now let us move on to question number 13. Question number 13 is assignment. It is directly from this. They are given det of A inverse. The same as what? Det A of whole power minus 1 or 1 by det. Okay. Determinant. Okay. Even now 14th problem. 14th problem. See this. Question says if A is a square matrix of order 2, so number of rows and columns are 2. If determinant of A is equal to 3, then what will be the determinant of A inverse? Determinant of A inverse. Yes, I'm not giving the options for 14th one. I want you to answer. Send in chat box. Till then, I will just write the next question options. You should just comment which of the following is not correct. First option, A into adjoint of A is equal to adjoint of A into A is equal to A into identity matrix. Option B, A into adjoint of A is equal to adjoint of A into matrix A is equal to determinant of A into I. Option C, A into B whole inverse is B inverse into A inverse. Option D, determinant of A not equal to 0 and determinant of B is also not equal to 0. Let's see how many of you have answered. Answer is very surely there in one among those. By using that, you have to get the answer. So Harini and Manikandan says it's 1 by 3. Yes, you are right. Determinant of A inverse, from here it is 1 by determinant of A. And in the question they are given 3. So 1 by 3 is the answer that is there. Yeah, Ananya, you also right. So for 14th problem, it is there in option C. Now come on, comment. 16th problem, if A and B are invertible matrices, then which of the following is not correct? Among this, which of the following is not correct? Yes. Till then, I erase the board. You comment it. Already, I think 2 have commented. Okay. And you know, this is what crystal clear formula and concept. How keen you should be about each and every formulas, concept. So moving on to question number 16, which of the following is incorrect? As you can see very clearly, A into adjoint A and adjoint A into A is given as matrix A into I. But we already know from the PUC fact that point number 5, you can see A into adjoint A is equal to adjoint A into A is determinant of A into I. Determinant of A into A, but here they have given A, therefore option A is incorrect. That's what we want. Whereas coming to option B is exactly matching with this, so there's no problem with this. And this we know inverse law that if I take inverse as well as transpose, the order of matrix A and B will get exchanged. And since in the question they said A and B are non-singular, for non-singular, determinant of A should not be equal to 0. So for both, it should not be equal to 0. Now one question. So how many of you have answered this? Let us see. Both Manikandan and Harini have answered. Good. Now the question to you is, can you say me which type of matrix is this? Determinant of A into I is which type of matrix? Think. Till then, next problem I have to dictate. Determinant of A. Harini says scalar matrix. Yes, it is scalar matrix. Reason, see carefully the reason. Determinant of A when we say into I. This part, see carefully. Determinant of A as it is. I, let us suppose 2 cross 2, so 1, 0, 0, 1. Multiplying what you will get. Determinant of A into 1 will be determinant of A. Then determinant of A into 0 is 0. Determinant of A into 0 is 0. Determinant of A into 1 is determinant of A. What is this? Scalar matrix. So it will be a scalar matrix. Yes. So it also means that if you just ask what type of matrix we are going to get for A into adjoint of A, your answer should be directly scalar matrix, because this is same as this equality is there. Okay. Now one question. Under what condition this can be a zero matrix? Under what condition this can be a zero matrix? Under what condition determinant of A will be a zero matrix? Okay, determinant of A should be 0. Determinant of A should be 0. Yes, Ananya. Fine. One more question. I have a lot of doubt, Yes, Manikandan, you also right. Halini, A should be singular. Yes, you are right. One more condition. One more question. Under what condition this will be a unit matrix? Determinant of A into I. Under what condition this will be what? Unit matrix. Determinant of A should be 1. Yes. Only then it will be what? Unit matrix. See, from here it's also clear that who knows, in MCQ purposefully they might have given only this, and they might have given what type of matrix is this? A into adjoint of A. Determinant of A is 0. Then what matrix? Determinant of A is 1. Then what matrix? We may think question is incomplete if you forget this property. And one more tricky case can be A is given to you. A is given to us 1, 2, 3, 4. Okay, or some, let us suppose A is equal to identity matrix or zero matrix. Then they might have asked this. Correct? So you should be very careful. There also adjoint of identity matrix is identity only. Adjoint of zero matrix is zero matrix only. Then product of two identity will be again identity. Product of two matrix 0 will be again 0. If A is identity, again this 2 will be identity. If A is zero matrix, this 2 will be again zero matrix. Or otherwise, we can see from here also. So many things we can think of framing the question now. Even when we are discussing also, you can think of framing the question. Okay, it's too good to have this fill. Okay. Now let us move on to the next question. Listen carefully and pay attention. It's a statement. All the statement problems means to say statements are there in the options. Listen carefully. This is on solution of system of linear equation. That is a 5-marker question. On that we have got. I will read the question for you. Listen carefully. For a square matrix A, in the matrix equation, AX is equal to B. AX is equal to B. So recall we used to have system of equation where A is coefficient of x, y, z and X is the column matrix having x, y, z. B is the constant in the right hand side. Then they're asking which of the following is not correct. First one, determinant of A is not equal to 0. This gives unique solution. They want incorrect. They want incorrect. So unique solution. This is unique solution. Next, option B. Determinant of A is equal to 0 and adjoint of A into B is not equal to 0. Then there is no solution. Then there is no solution. Option C. If determinant of A is equal to 0 and adjoint of A into B is equal to 0, then the system may or may not have, I repeat, then the system may or may not be consistent. May or may not be consistent. And option D, okay, may or may not be consistent. Lastly, option D, determinant of A is not equal to 0. The system is inconsistent. First, recall what do we mean by consistent and inconsistent. If solution exists for the system of linear equation, we say it is consistent. If solution does not exist, then we say it is inconsistent. Solution exists for system of 2 equation and 2 unknown. That equation represents pair of line. So when I say consistent, no, we have a solution. It can be unique solution or it can be infinitely many solutions. First, understand the concept. So if I talk about 2 equation and 2 unknown, then it represents pair of line. So here we can see the lines are intersecting. So we have a unique solution. For this unique solution, we are saying that determinant of A should not be equal to 0. What is the unique solution? As soon as solution exists, we say it is consistent. Consistent means solution exists. Whereas you see this one line is here and one on that I'm overlapping this. Now this is also consistent, but we have infinitely many solutions. And here determinant of A is 0. And one more case is there. This is case number 1. This is case number 2. Coming to case number 3. And one more line here. They are parallel line. There is no solution. Here also determinant of A is equal to 0. What I'm trying to convey here is, as soon determinant of A is equal to 0, many students have this habit of commenting that solution does not exist. It's wrong, wrong, and wrong. As soon determinant of A is 0, we have 2 cases. No solution or infinitely many solutions. Only one case is exempted. As soon determinant of A is equal to 0, unique solution gone. We have 2 cases. Here, infinitely many solution. Infinitely many solution. And here, there is no intersection, so there is no solution. For no solution, we can say it is what? Inconsistent. For the infinitely many solution, we say it is again what? Consistent. Consistent, whether it is unique solution or infinitely many solution, we say it is consistent as soon solution exists. Now you see, they ask which of the following is incorrect. Determinant of A not equal to 0 is inconsistent. No, it is consistent. So option D is incorrect. And so all are correct. Determinant of A is not equal to 0, unique solution. As soon determinant of A is equal to 0 in both the cases, find the adjoint of A into B. If it is not equal to 0, no solution. Equal to 0, may or may not be consistent. Now listen carefully. This is NCERT textbook version of this 3 statement. Okay. This is there just before exercise 4.5. When the mark is given on this 2, you should remember, and that's what I have taken the problem. But coming to solve the problem, no, we are not going for this approach, which we'll be seeing shortly in case problems being asked. For line, yeah, I have taken a problem on line. Then I will discuss how we are going to go without going for this. But if it's three equation, we have got some other logic when we take CET classes. That time we will discuss. I hope this is clear. Kindly comment. I've spent some time for concept here. Is this clear? Now, I am writing one question here. Get me the solution of that. Till then, I will erase the board. Question is, I want you to solve this problem, as I hope that you should be aware of evaluating 3 cross 3 determinant. Question number 18. It says, if A is equal to 1, 2, minus 1, 1, x minus 2, 1, x 1, 1 is singular. If this is singular matrix, find the value of x. For singular, determinant of A should be 0. Come on, determinant of A should be what? 0. Get me the answer for this. Take determinant of A to be 0 and get me the answer for this. I'm waiting. What's the answer? I'm waiting for your answers. So I would like you to solve, and the answer for this should be 2. After you solve, you'll get x is equal to 2. I expect you to solve from here, and that is there in option A. Okay. Now let us move on to question number 19. 19th question. Before that, 20th question I'll take first. Question is, if A is equal to 2 lambda minus 4, 0, 2, 5, 1, 1, 3, then A inverse exists. A inverse exists if for what values of lambda A inverse exists, they are saying. See, inverse of a matrix exists if it is non-singular. Nothing but determinant of A should not be equal to 0. So evaluate the determinant 2 lambda minus 4, 0, 2, 5, 1, 1, 3, and this should not be equal to 0. Let us take it here. So here it is plus, minus, plus. So 2 times of, leave this first row and first column. If you leave this first row and first column, 2 3s are 6, minus 5 1s are 5. Then minus lambda, leave the first row and the second column. 0 into 3 is 0. Minus 1 5s are 5. Minus 4. Plus it minus 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 4. Leave the first row and the third column. 0 Okay, 0 into 1 is 0 and minus 2. 0 minus 2. This should not be equal to 0. Now simplify. 2 minus 6 is 1. 0 minus 2 is minus 2. So 2 into 1 is 2. 0 minus 5 is minus 5. Minus minus plus 5 lambda. Minus minus plus 4 2s are 8, not equal to 0. So 5 lambda, 2 plus 8 is 10, not equal to 0. 5 lambda should not be equal to minus 10. 5 ones are, 5 twos are, lambda should not be equal to minus 2. So if at all this should be invertible, lambda should not be equal to minus 2. It also means that if lambda is equal to minus 2, then the given matrix will be singular and it will not be invertible. Nothing but inverse does not exist for lambda equal to minus 2. Okay. It can take any real number other than minus 2. Then lambda, if I repeat, if lambda take any real number other than minus 2, then this matrix inverse exists and hence it is invertible. It is singular and sorry, it is non-singular. And I repeat again, for lambda not equal to minus 2, whichever number you want to take other than minus 2, then the matrix determinant, if I take, it will be not equal to 0. Therefore, it will be non-singular matrix and hence it will be invertible. Whereas for lambda equal to minus 2, it will be a singular matrix due to which inverse does not exist. Okay, fine. I hope it's clear. Fine, let us move on to the next. Moving on to question number 21. You have to find the inverse of this matrix. Come on. Let us find it. Take the given matrix BA. Surely for 5 marker 3 cross 3 have been learning. Now 2 cross 2 I have taken here. Let us recap once. Formula to find inverse of a matrix, as you can see here. So first find the determinant of A. Determinant of A here, it is plus minus. So 2 6 are 12. Then 4 3 are 12. 12 minus 12 is 0. Oh, it is 0 as we discussed. If determinant of A is 0, the matrix is singular and hence inverse does not exist. Yes, in option D we have got does not exist. Always first find determinant of A. Should not happen if on adjoint. Anyway, here adjoint A is not such a big lengthy calculation. But for 3 cross, yes. So always try to find what? Determinant of A. That's why you read 5 marks also, no? First you find determinant of A. But in 5 marker, they will not give you determinant of A equal to 0. Then it can't be framed as 5 marker question. Since the determinant of A not equal to 0, we are able to get unique value for x, y, and z. Solution is unique. Question number 22. Let's take the problem. Actually, at the beginning of the matrix problem, we had a question on finding the inverse. So there I said assignment not to solve this here. I thought I'll take where I'm taking determinants. So question is this: if the matrix is this, we are taking as A, 2, 2, 4, 3. Come on. See here how we are going to find the inverse. First, find the determinant of A. How to find plus minus? 3 2s are 6, minus 2 4s are 8. 6 minus 4 is minus 2. Now I want adjoint of A. How to find adjoint of A? We have to exchange the diagonal element. 2 3 will change to 3 2. Then we have to change the sign. Be careful. Plus minus, I wrote for expand determinant. This is the sign, correct? No. So sign of 2 is plus, change to minus. Sign of 4 is plus, change to minus. Therefore, inverse of the matrix is 1 by determinant of A into adjoint of A, where determinant of A should not be equal to 0. Therefore, A inverse is 1 divided by determinant of A is minus 2. Then adjoint of A is here 3, minus 2, minus 4, and 2. Let us see the option. Have they further simplified? Minus half, 3, minus 2. Okay, they have taken negative in. If I take negative in, minus into plus is minus 3, then plus 2, plus 4, minus 2. So minus 3 to 4, minus 2. Minus 3 to 4, minus 2. Option Bablu is correct. Option Bablu is correct. Now let us move on to next. Let I erase the board. Just give me a minute. Okay. Let us move on to the next question. Now consider question number 23. Question number 23. What it says. Question number 23 says, consider the following linear equations. This is the linear equation. 3x minus 2y plus 3z is equal to 8. 2x plus y minus z is equal to 1. 4x minus 3y plus 2z is equal to 4. The system has option A, exactly 3 solution. Option B, a unique solution. Option C, no solution. Option D, infinite number of solution. So they're talking about how many solution or the behavior of this they're asking. So first, write the matrix here. Only the matrix here, that is coefficient of x, y, z, will play the role in deciding the consistency of the system of equation. X multiple 3, y multiple minus 2, and here it is 3. X multiple 2, y multiple 1, there's no multiple but 1. 1 into y is y. Then here it is minus 1, then 4, x multiple is 4 here, then minus 3, and then 2. We have to find the determinant of here. Here it is plus, minus, plus. I'm just skipping on some steps here. We are not in 2, 3, 4 marker. Usually in class, I'll say we are not in PUC. We are in PUC, but we are not in 2, 3, 4, 5, 6 markers. Okay. Plus into plus, plus 3. Leave the first row and the first column. What will you get? 1, minus 3, 2. Then minus minus plus 2. Leave the first row and second column. 2, minus 1, 4, 2. Then plus 3. Leave the first row and the third column. 2, 1, 4, minus 3. Plus minus, plus minus, plus minus. So 3 times of 1 into 2, 2. Minus minus plus, plus into minus minus. 1 into 3, 3. Then plus 2 times of 2 into 2, 4. Minus minus plus, plus 4. Then here plus 3 times of 2 into minus 3 is minus 6. Minus 1 into 4 is minus 4. So you get minus 10. Here you get 8, and here you get minus 1. So you get minus 3, 2 8s are 16, minus 30. Surely this is not equal to 0. I don't want a particular value. I mean, set a fixed number, whatever they're getting, I don't want. I only focus on is determinant of A is 0 or non-zero. Surely the simplification of this will not be equal to 0. This will be a negative because 16 is less than 30. So this will give negative, minus negative will be a negative number, not equal to 0. So we will have unique solution because determinant of A is not equal to 0. This implies we have unique solution. But you have to be very careful in the option. No, one trick is there. What? In the option, they have said first option exactly 3 solution. Second is unique solution. Many students will think of option A exactly 3 solution. Reason, x value we will come to know 1 value, y value 1 value, z. So 1 1 1 3 values they will think. 3 values so 3 solution they will think. Since 3 values, what they will think? 3 solution. 3 values you got, but not 3 solution. These 3 together forms the solution for this one solution. One solution. Okay. Counter is for 3 values, but it's not 3 solution. So these 3 values putting here x, y, z will form a one solution, unique solution. When we say 3 values, it means what? For x, y, z, we should have 3 answers, and all those 3 answers should satisfy this, which is not going to happen. Either unique solution or many solution. Okay. Fine. Any doubt before proceeding? Any doubts before proceeding? Okay, let us go for the next question. Okay, money content, no doubt, fine. Moving on to the next problem, question number 24. This question is usually a 4-marker. In 4-marker, we have got this question. Finding the inverse, question number 24. They have given if a square minus 4a plus I is equal to 0 matrix, then the inverse of a is. They said in the statement form inverse of a is, I wrote a power minus 1. Now to find inverse of a, multiply throughout by what? A inverse. And I multiply throughout by a inverse, we are going to have a inverse a square minus 4a inverse a plus a inverse I is equal to a inverse into 0 matrix. Now, see, since we are not in PUC, I can just play some rudely, I can calculate what basis asim at the power, which is not correct. But since it's not in PUC, I can just play this. 2 minus 1 is 1, so a power 1. Here power of a is 1. 1 minus 1 is 0. A power 0 is identity matrix, which is not correct. Okay, again I'm saying. And whenever you multiply any matrix with identity, we get back same matrix because of the reason A into identity is A itself. And whenever you multiply any matrix with 0 matrix, what you will get? 0 matrix always. Now I want A inverse. This 2 I can transpose the other side. We get A inverse is equal to minus A plus 4I. A inverse is minus A plus 4I. That is in option B. Is this clear? Any doubts before proceeding? Okay, clear is the message. Text, fine. Let us move on. Next problem. Let us move on. Next problem. Kindly pay attention. Listen carefully. Here it is wet. Okay. Now let us proceed with the next problem. Kindly pay attention. Listen carefully. So the question says now is question number 27. Okay, question number 27 will be assignment. Now that we had no system of equation, I'd say unique solution, many solution, no solution. It is on the same thing. They have again given 2 to 3 times that I don't want to again solve. So question number 27 will be assignment. Just that note you can, that question you can see and always you can answer. Now question number 28. Question number 28 says, if A and B are square matrix of order 3, so order is 3, and they are saying determinant of A is equal to 5, determinant of B is equal to 3, then what is 3 times of determinant of A into B? I would like you to send the answer. Till then, I will mention the next question. Question number 29, I'm writing here. If A is a matrix of order 3, then what could be A into adjoint of A? Okay, adjoint of A is 10 times of determinant of A. Then what is determinant of adjoint of A? They are asking. Next, one more question. Okay, that I have to read. So fine, let us go one by one. Pay attention. Pay attention. So you're answering. We'll do one thing. We'll have a break now for some 10 minutes. Then we will take over. Okay. 10 minutes break we will give. Don't need to log out. I'll also not end the live session. Now time is 5:01. On 10 minutes break we'll take. Now time is 5:01. We start the class at 5:11. Okay. Is that fine? Kindly comment. Okay, yes. So I mentioned here break. Don't leave the live session. Okay. Okay, we'll have this emoji also like this. No, no, this is like crying. Yeah. This is sweet. Okay, many things I'm learning. Okay, I'll mute myself. Yes, I'm back. We'll start with the class now. Kindly comment, am I audible? Just give me a minute. Okay. Okay, fine. Yeah, kindly comment. Am I audible? Okay, yes, fine. Welcome back. Now let us proceed with the class. Okay, last problem. Let's top 29. Okay, we have to solve this problem. Yes, what's the answer? Are you ready with the answer? Question number 28 and 29. Break them. Okay. So Ananya is saying 405. Okay. So let's solve it. See, when we are starting this, the question says the order of the matrices are 3. Determinant of A and B is given. You see, we have to find determinant of 3 times of A, B. See, 3 is a scalar. A into B is one matrix for level. Consider product of these two matrices, one matrix. This is going to go exactly with this. So K can come out with the power of order of the matrix. K is 3 here. So 3 power n is 3. Then determinant of AB. 3 power 3 will be 27. Determinant of A into B is determinant of A into determinant of B. Individually we can write. Now 27 times of determinant of A is 5. Then determinant of B is 3. 5 3s are 15. So 27 into 15. Simplify. Okay. So here, question number 28. Answer will be 40. Okay, if you multiply, you get 405. Yes, Ananya, you are right. 405, option E is correct. Moving on to question number 29. The order of the matrix n is 3. A into adjoint of A is 10 times of I. Then we have to find adjoint of A determinant. So here, don't forget from this, can you see the last one? Determinant of A into I, determinant of A into I. So this is actually determinant of A. 10 is determinant of A. So determinant of adjoint of A is what? Determinant of A whole power n minus 1. Determinant of A is 10. N is 3. So 3 minus 1 will be 2. 10 square is 100. So which option is this? Option D. Okay. Now I will read question number 30. It's a statement. In all the options we have got statements. You have to listen the statement carefully and then you are going to answer it. Okay. All fine. Yeah. Now see carefully and pay attention. Before I go ahead, whenever you multiply the element with its cofactor, I hope you know this cofactor concept, cofactor minor. See, when you are going to expand any determinant, let's have this concept once. If I am going to expand the determinant, suppose I got a matrix A with element A11, A12, A13, then matrix element here A21, A22, A23, A31, A32, and A33. Whenever I'm going to multiply any element with its cofactor, then the value of the value of that will be, I repeat, whenever we are going to multiply any row with its row cofactors or any column with its cofactors, then the value will be value of the determinant. For example, here A11, what is the cofactor of this? Capital A11. Then plus A12, what is the cofactor of that? Capital A12. Then here for A13, multiply the cofactor of that A13 capital. How to get cofactor? Cofactor is given by Aij is equal to minus 1 power I plus j into Mij, where Mij is minor. How to get minor? Delete the row and column. I'm not able to know. Yeah. Delete the row and column where the element is lying in the matrix. For example, here minor of A11 will be, delete this row, this is column, A22, A23, A32, and A33 will be the minor. And here one more interesting thing to be understood is, since this will be the minor, this order is what? 2 cross 2. And the given matrix order is what? Or determinant, if I take also this, will be of order 3. So always minor order will be 1 less than the given determinant, where n will be either greater or equal to 2. Minimum the order of the determinant should be 2 to get, I repeat, minimum the order of the determinant should be 2 to have a minor. For example, here, if I give you determinant A, B, C, D, I want the minor, nothing but delete the row and column where the element is present. So here, if I want to find the minor of A, delete the row and column where it is present. D is the minor of A. D is the minor of A. Similarly, minor of B will be C. So just see, on the whole, the order is what? 2. But as soon as I find the minor, the order is what? 1. So minimum order of the determinant should be 2. If I want what? Minus. If it is something like this is the determinant of order 1 cross 1, I cannot find the minor of this. Because if I want to delete and write the element, I don't have any element. Okay. No element doesn't mean a 0. 0 means the count of the element. I'm talking about a particular element. I hope this point is clear. And here, you see, whenever we multiply any row with its cofactor, we get value of the determinant. Value of the determinant. Whereas if you multiply a row with some other cofactor of rows, I repeat, if any row is multiplied by some other row cofactor, value will be 0. Similarly for column also. That's how we are going to get this result also. Fine. Having this logic, one more thing I want you to understand. See this. How to know a particular element taken from which row or which column? You see this A11, A12, A13. So since first index, always don't forget, in any of the concept of matrices, the first index stands for row, second index stands for column. So since first index is always same here, 1, 1, 1, O is first row. Let us suppose the second index is same, 2, 2, 2, second column. Okay, so when you see here, 1, 1, 1, oh, first row elements they are. First row elements, these are first row elements, small a, and capital A is what? First row cofactors. First row cofactors. So having this, let us proceed with the problem. Before proceeding, any doubts? Can you go ahead for the statement problem? Any doubts? Kindly comment. Okay, no doubts. Fine. Okay, moving on to the problem. Question number 30, I'm going to read the statement. Which of the following is not correct? You have to say which of the following is not correct. So as in how I read the statement, first you comment correct or not. Okay. Options. In options, all are statements. Okay. So the first option A is a square matrix is said to be singular if determinant of A is 0. First option is a square matrix is said to be singular if determinant of A is equal to 0. Yeah, that is true. But they want incorrect. Option A out. Option B. If elements of a row or column are multiplied with its cofactors of any other row or column, then their sum is 0. That's what I discussed here. If you multiply the element with its own cofactor, we get value of determinant. But if you multiply a row with some other row cofactor and a column with some other column cofactor, then the value of the determinant will be always 0, and that is not the value of the determinant. And also you should remember. So this fact is also true. This is also true. This is also true. Option C. Square matrix A is invertible if and only if A is singular matrix. What do you say about this? I repeat, a square matrix A is invertible if and only if A is singular matrix. I want your comments. This is correct? What I just read now? Is option C correct? While texting, Ananya is saying false. Better no? For option you give C, then the comment. Arvind says incorrect. Yes, you are right. This is a false statement. What was the statement? Statement says for no, invertible. For invertible should be a non-singular matrix. So option C is incorrect. Coming to option D, let us know that also. A square matrix A is said to be non-singular if determinant of A is not equal to 0. For non-singular, determinant of A should not be equal to 0, and this is a true fact. We want the false fact. Fine. I hope this is clear. Let us move on to the next. Before proceeding, any doubts? For a while. Okay. This is a very good platform, I think, where even after college hours you can think of going through, and good. We are able to relate, we are able to utilize the time efficiently. Now moving on to next question number. Okay, question number 33 is assignment. Assertion isn't a question. What we discuss about odd order of skew symmetric, on that it is, so assignment it is. Coming to question number 34 is again on this concept, assignment. 35 is again on singular, non-singular assignment here. This 3 assignment. Now let us move on to 36th question. Kindly pay attention, listen carefully. Coming to question number 36, listen carefully. This is the fill in the blanks question. If A is matrix of order 3 by 3, so A is a matrix of order 3 by 3, N is 3 by 3. The number of minors in determinant of A is. So how many minor can we have? If A is a matrix of order 3 cross 3, else you will answer. A is a matrix of 3 cross 3. How many minor can we have? Number of minors. I'm waiting for you to comment. Manikandan says 9. See, all of you. Let us suppose I got one element. Okay, 3 cross 3, no? Now see, minor. Minor of this, I'll have one element. For this, how to find the minor? There is a student column, correct? No. So for this, I will have one minor. For this, also one minor. Each element will have one minor. So number of minor will be equal to number of element present in the matrix. Number of element present in the matrix is 3 into 3, nothing but 9. These many minor also we are going to have, because each element will have a minor. Is this point clear? So option yes, Harini, Manikandan, you're right. So we are going to have for question number 36, 9, fill in the blanks. So 9. Moving on to question number 37. Listen carefully. Question number 37 says, if A is Aij, a square matrix of order 3, and determinant of A is equal to 3, and order of the matrix is 3, then what is the value of, okay, see carefully this expression, value of A11, A21 plus A12, A22 plus A13, A23, where Aij is a cofactors of small aij. Capital Aij is cofactor of small aij. Now, as I said, that's what I was talking about. How to know just by seeing which element is which row element it is and which row cofactor or column cofactor it is. Just see first small a. In small a, see which index is same throughout. In small a, why did I take a marker? Yeah, in small letter a, which is always same, which index is 1, 1, 1. So all our ai's, a small a is first row element. First row element. Now see about the cofactor. Cofactor, you see which is same throughout. In cofactor, if you see, again you see a 2, 2, 2. So coming to cofactor Aij, this is the cofactor second row. Second row cofactors. Second row element cofactors. Second row elements cofactors. So here first row element is multiplied by second row cofactor. Therefore, the value of this expression sum should be 0. Is this point clear? I want you to comment. Is this point clear? Have you understood this? Okay, Harini content has commented. Yeah, clear. Good to know. Moving on to next problem. Question number 38. Question number 38 is, it says, if A is an invertible matrix of order 2, then what is determinant of A inverse? Now for this, we have two approaches. I'll solve both the approach. First approach is, what is A into A inverse? Identity. Determinant of identity is what? 1. Job done. Other approach, determinant of A into A inverse is same as A and A inverse both are what? Matrices. Determinant of A into B is same as determinant of A into determinant of B. So I can write like this. Determinant of A inverse is 1 by determinant of A. So this one as it is into 1 by determinant of A. Both will get cancelled. Answer is 1. That's what both will give the answer. This was so direct just by using the concept of invertible matrices. So for question number 38, answer is, okay, 1. This is the fill in the blanks question. 1 is the answer. 1 is the answer. Fill in the blanks. Now moving on to this question. Did I erase this? Now moving on to this, that means next problem. Question number, which was 38, no, 39 will be assignment. Coming to 40, if A is a square matrix of order 2 and determinant of adjoint of A is 9, then we have to find determinant of A value. Think about the solution of this. Then I write 41. If A is equal to 1, 1, 3, 2, then what will be 2 times of A transpose determinant? Question number 42. If A is a square matrix of order 3, determinant of A is 3, then what is the value of A into A transpose determinant? Then question number 44. If A is a square matrix such that A square is equal to identity matrix, determinant of A is not equal to 0, then what is A inverse? Let's take one by one. Yes, question number 40, answer. What is the answer? I am waiting. Halini and Ananya says answer is 9. Let us see. See, determinant of A we want to find. Don't forget determinant of adjoint of A. That's what I said. No, I gave all the formulas. Determinant of adjoint A is determinant of A whole power n minus 1. So this will be determinant of A whole power n is 2. So 2 minus 1. Correct? No. What is order given? 2 or 3? Order is 2. 2 minus 1 is 1. Determinant of A is equal to 9. Yes, you are right. Fill in the blanks. Coming to this question, A is given. We have to find 2 times of A transpose. Many will think first we find A transpose, then we multiply by 2. Not at all required. 2 into A transpose is a matrix. Scalar into matrix. Scalar into matrix is here. I can take 2 out. Don't forget, if it's a square matrix, A matrix and A transpose matrix order will be same. So since order is 2, so 2 power 2, and here A transpose. But we know that A transpose and A determinant both are same. Where I wrote somewhere, I don't know. Here, both are same. So this is same as 4 times of determinant of A. Determinant of A from here, plus minus 2 ones are 2, minus 3, answer is minus 1. So 4 times of minus 1, nothing but minus 4. Minus 4 is there in which option? Okay, so again, fill in the blanks. Minus 4 is the answer. Have you commented any answer? Yes, yeah, Hadini has commented. Come on, comment about this. If order of the matrix is 3, determinant of A is 3, what is A into A transpose? Again, A into A transpose. First, by using this 0.8, determinant of A into B is, we can separate together. So I can separate amend them. So determinant of A into determinant of A transpose. Determinant of A is 3. And determinant of A and its transpose both are equal. So this will be also determinant of A, nothing but 3. 3 3s are 9, because determinant of A transpose is equal to determinant of A itself. Now come to this. Be careful. They are saying if A square is equal to identity matrix, A is non-singular matrix, then what is A inverse? Now here there is no determinant involved. I want A inverse. Very simple. Multiply by A inverse. So how to know that we have to multiply by A inverse? Because A inverse is asked. It's like a 4-mark question is there, no? First we have to prove and then find the A inverse. There's a multiplying A inverse throughout. So we will get A inverse A square is equal to A inverse identity. Here bases are same, we can add the power minus 1 plus 2. Hello, bases are same, add the power just for 1 marker I'm saying. Otherwise we have to write A into A, then freeze the things, correct? No? So I get only A. Okay. Then here A inverse into I will be A inverse itself. So inverse of the matrix is A itself. Okay, thank you for your feedback. Now for this, which option? Question number 44. Question number 44 is there. Okay, option C is fine. Let's comment. Any doubts before going ahead? Let us move on to the next question. Question number 44 done. 40. Oh, I have not made a note of this question number. Question is this. This is there from the question bank, but I think I've forgotten to make a note of this. Anyway, I write the question for you. We have to, I've just missed. Find the value of this. Come on, very simple. Plus minus, multiply. Cos into cos will be cos square. 15 degree minus sine to sine, sine square 15 degree. Recall multiple angle formula. What is cos square x minus sine square x? It is cos 2x, double the angle. So x is here 15. Double of 15 will be 30. Correct? No. If x is equal to 15 degree, as you can see here, on 2x, so multiply by 2. 2 into 15 will be 30 degree. So this will be cos 30 degree. What is cos 30 degree? Root 3 by 2. Root 3 by 2. That is in option blue. Okay. Question number 45 is assignment. See, in case from here, if in case the questions are not matching with the question bank, when I see, then what I will do, I will retain the question, and for this I will give as Q. Okay, because there should not be a mismatch when we are going through with respect to my class. 46th question. Any comment is in the chat box. Fine, let us proceed. Kindly pay attention, listen carefully. Question number 46. Yeah, I will read the question for you. Given that A is equal to small aij is a square matrix of order 3 by 3, so n is equal to 3, and determinant of A is equal to -7, then the value of summation of I running from 1 to 3, AI2, AI2, small AI2 and capital AI2, and capital Aij denotes the cofactor of the matrix small aij. Then we have to find the value of this. Don't forget this symbol stands for summation. So I is running from 1 to 3. Put I equal to 1 here. What you will get? I equal to 1. So 1, 2, A1, 2. This symbol stands for addition. So plus again A2, 2, capital A2, 2. Plus put I equal to 3. A3, 2, capital A3, 2. See what's happening? Many of you want to know, sir, where are these elements when the question? Concept. We know that if a row is multiplied by its own cofactor, the value will be value of determinant. Similarly, if a column is multiplied by its own cofactors, same column cofactors, then also the value will be value of the determinant. But if a row is multiplied to some other row cofactors, similarly a column is multiplied to some other column cofactors, then the value will be 0, which is not the value of determinant. Need not be better. So see carefully, see the index, follow the index version. No one have commented. Okay. Follow the index. Which index is same? Coming to element aij, small aij. See this 2 here, 2 here, 2 here. Okay. Aij means yeah, small aij is element of second column. Elements of second column. I hope you're understanding how to know the elements. Very simple. See the second index. See the index in which the index are same. So as you know, always in A, I, J, first index stand for row, second J index stand for column. So you can see 2, 2, 2. So it's column. Coming to capital A, I, J, see which index is same. 2, 2, 2. Okay. These are the cofactor of. So capital A, I, J. Capital A, I, J are cofactors of second column element. Second column elements. Therefore, this will give you, see, second column element is multiplied by second column cofactors. Therefore, the value will be value of the determinant. Value of the determinant is given as -7. So -7 is the answer. Is this clear? Kindly comment. Any doubts? Okay, Manikandan Nanya says clear. Fine, let us move next. Now moving on. To the next question, number 52. Question number 52. This says the system of equations, that is 4x plus 6y is equal to 5, then 8x plus 12y is equal to 10 has option A no solution, option B infinite many solution, option C unique solution, option D trivial solution. See, for this I'll give you other concept than going for adjoint. Okay, listen carefully. School days concept. See, coming to two equation and two unknown. I mean to say system of linear equation in two variable represents pair of line. Coming to pair of lines, let us first give the concept. Listen carefully. Coming to pair of lines, let us suppose the line is L1 is A1x plus B1y plus C1 is equal plus C1 is equal to 0. Then the line L2, I'm giving a concept here, very simple concept of school days. A2x plus B2y plus C2 is equal to 0. Now coming to plane in 2D, we have got three behavior of the line. First, the line can be intersecting. Second, the line can be parallel. Third, the line can be coincident. Coincident when I say overlapping. Now, overlapping. Now see carefully. Intersecting. This is line L1 equal to 0. This is the line L2 is equal to 0. They are intersecting here. Unique solution we have. So whenever the lines are intersecting, we have got here unique solution. Unique solution. And hence it is consistent. And hence it is consistent. Whenever solution exists, we say it is what? Consistent. Consistent. Now, condition for consistent will be, if I take the ratio of x multiple, that is a1 by a2, will not be equal to the ratio of y multiple b1 by b2. Whether it's equal to constant or not is bothered. This two ratio, if I take, it should not be equal. From this, actually, from this reason, because of this itself, determinant concept came into picture, which I have discussed in PUC at the beginning of chapter determinants. Coming to parallel, the lines are like this. they are not intersecting. So this is L1 is equal to 0, this is L2 is equal to 0. The lines are parallel. Since lines are parallel, they are not intersecting. Since they are not intersecting, there are no solutions. No solutions. Hence, inconsistent. Now, since inconsistent, here the ratio of x, that is A1 by A2, is equal to B1 by B2. This will not be equal to C1 by C2. The ratio of Ax multiple y multiple will be same, but not equal to the constant. Next case is coincident. Nothing but the line is going to overlap. This is L1 equal to 0. One more line here. Okay. This line is L2 is equal to 0. Since it's overlapping, I have got infinitely many solutions. Solution means they should have common values. Both should satisfy for the same set of value. The way here it is one value, it will be satisfying by matrix method, school substitution method, elimination method, cross multiplication method you have used to find it. Correct? Now here we are going to have infinitely many solutions. Infinitely many solutions. And having this, for this the condition will be A1 by A2 should be equal to B1 by B2 should be equal to C1 by C2. For parallel, it will not be equal to constant ratio. And here it will be, since solution exists, okay, infinitely many solution, therefore it will be consistent. Therefore it will be consistent. Now if I talk with respect to determinant concept, here determinant of A is not equal to 0. That's what it is unique solution. Okay, consistent. Here determinant in this both cases, determinant of A is equal to 0. That's what I'm saying. As soon determinant of A is equal to 0, don't comment that solution does not exist. We have two cases. As soon determinant of A is 0, we can have either no solution, nothing but inconsistent because of parallel line, or we can have infinitely many solution, nothing but the lines are overlapping, nothing but coincident lines. Coincident parallel lines here. This is coincident lines. And here intersecting lines. The word lines is not mentioned. Now let us come to this question. They're talking about the solution. No? Now come on, take the ratio of this. 4 by 8, 6 by 12, 5 by 10. See, coming to concept, either you keep both to the left or both to the right. Ultimately, you get same answer. For example, if you want to transfer the left, no, this will be -5. Again, it will be what? -10. So I'll have -5 and -10. Negative will get again cancelled. That will not be a big deal. Okay. Ultimately, you get same. 4 ones are 4 twos are, 6 ones are 6 twos are, 5 ones are 5 twos are. The ratios are equal. And it goes with this. Therefore, we have infinitely many solution. So many solution. Hence consistent. So which option for this? Let's check. Question number 52. Option blue, infinitely many solution. Only in one line you can get, no need to go for adjoint here, then multiply with B, then you have to see equal to 0, no solution, not equal to 0. It depends on the system of equation, may or may not have solution, correct? So as soon determinant, I mean to say adjoint of A into B is, okay, not equal to 0, we have to think of two reasons. We are not going to get ultimately the answer for that if it is not equal to 0. Fine. Now let us move on to the next problem. Any doubt before proceeding? Kindly comment. Before proceeding, any doubts? Okay, some comment has come. Can we use 3 lines? Coming to 3 lines, Anya. See, coming to determinant now. Coming to determinant, as it goes for only what? 2 cross 2, 3 cross 3, but 2 cross 2 or 3 cross 3. Now coming to 3 lines, the question will be like this. Listen carefully. I have line number 1, line number 2, line number 3. Coming to determinant, we'll say it is co-concurrent. Concurrent means all the three lines. Concurrent means all the three lines are lying on the same plane. And this line equation, I understand what you're saying. Just this. This line equation will be like this. These are the three lines. I understood. I'm going to coming to your point. Now I understood you are taking a three lines question with respect to three equation, three unknown. As soon as you have a three equation, three unknown, it's not equation of line, it's an equation of plane. And for that, this logic is not there. But in entrance, I'm going to discuss one concept. What we can do is I can eliminate first forever. First, I hope this point is clear. If at all we are using determinant concept for this one, no, it was a for line, for three line. This is the three line equation. And we say concurrent means all the three lines should pass through a common point of intersection. Okay. And for that, determinant of this A1, B1, C1, A1, B1, C1, A2, B2, C2, A3, B3, C3 should be equal to 0. Coming to determinant, this is for concurrent line. Till here, I hope you are okay. Now I come to your doubt. Ananya, I think your doubt is in 5-marker question. We are also having consistent, inconsistent. There we have to find adjoint A into B if determinant of A is 0. You're talking about this, correct? Kindly comment. Are you talking about three equation, three unknowns? Yes. For that, we don't have like this trick. What we are going to do when I take, we have either Cramer's rule or I'm going to eliminate one of the variable. Let us suppose Z by using there are three equations, no? 1, 2, 3. Use 1 and 2, eliminate Z. Again, use 2 and 3, eliminate Z. As soon as I eliminate Z, I'll have what? Two equation containing X and Y. Then I'll come back to this concept. That's one way. Other ways using Cramer's rule. Okay, so presently there are no questions asked here. So we have not taken any problem, but yes, for CET, surely I will try to take that type of question as well. Okay, is that fine? What I said orally, that time I will surely solve and go ahead. Okay, kindly comment. Can we go ahead? Is that fine? Okay. But coming to 3 cross 3, surely for MCQ, it will not be there. Okay. Actually, that is in JE, but surely I'll try to see for CET at least. Okay. So I think this is fine. Now let us move on to the next. Moving on to the next question is yes, question number 53. What question number 53 is saying? If A and B are invertible matrices of the same order such that A into B the whole inverse determinant is 8, and if determinant of A is 2, find the determinant of B. Come on, I am waiting. Next 56th I have to dictate. 57th I will write it here. Try to solve. If A is a square matrix of order 3, determinant of A is equal to 4, then what is A into adjoint of A determinant? This is one more question. Question number 58. If A is equal to 1, 3, 4, 2, B is equal to 2 minus 1, 1, 2, then what is determinant of A, B, B transpose? Let's try to go one by one. And 59 is assignment again on system of equation, adjoint A B concept, which we already discussed. 3 questions they have asked the same thing. Let's see what's the answer. 53rd. What is 53rd answer? Ananya says 4. Harini says 1 by 16 for the 1. Okay, let's solve now. All of you, pay attention, listen carefully, focus. Question number 53. See this determinant of AB the whole inverse. AB the whole inverse. Now here I can surely apply, where is that? Yeah, this one. So I can just take to denominator 1 divided by determinant of AB is equal to 8. Determinant of AB from this is same as determinant of A into determinant of B is equal to 8. Again from here 1 divided by determinant of A is 2, then determinant of B is equal to 8. Cross multiply this. 8 into 2 is 16. So 1 by 16 is equal to determinant of B. So determinant of B is 1 by 16. Yes, I hope Ananya, is it clear why it is wrong, beta? Both Harini and Manikandan got the answer. Good job. 1 by 16. Okay, good. So question number 53, answer is option D. Moving on to question number 56. I will read the question. Listen carefully. It's a statement question. You have to answer it, okay? Question number 56 says, if the value of third order determinant is 6, if the value of what? Third order determinant is 6, fine. Then the value of the determinant formed by replacing each of its elements by its cofactor. I repeat, then the value of the determinant formed by replacing each of its elements by its cofactors. What is that matrix in which we are going to have cofactors in place of elements? Can you first say me what is that? Which is that matrix? As soon we replace element by cofactors, what is the name of that matrix? Where we are replacing the elements by cofactors? Anyone? Transpose of adjoint. It is just adjoint. Adjoint is transpose of cofactors. Any? It's only adjoint of a matrix. What is adjoint of a matrix? Transpose of cofactors. So yes, you are right. It's adjoint. Okay, only adjoint of the matrix A. So they are saying I have to find the value of this. I hope this point is clear. With respect to this question. Okay, fine. Yes, you are right. So because they have not taken transpose of cofactors, yes. So it is this. Then we know transpose of adjoint. Transpose of adjoint. Okay, transpose of given matrix is same as the given matrix. So because of that reason, this will not play any vital role. But to be specific, she's very right. Then this is determinant of A whole power n minus 1. Determinant of A is 6. N is 3. So 3 minus 1 is 2. 6 square is 36. 36 is the correct answer for 56. Option Bablu. Next, 57. See 57. If A is a square matrix of order 3, determinant of A is 4. We have to find what is A into adjoint of A. Let us see who will answer. A into adjoint of A. I'm waiting. Harini says 64. What about rest? Okay, let's compute. See here, don't forget adjoint of a matrix A. Adjoint of a matrix A is again a matrix. So A is already a matrix. So both are what? Two matrices. So A into B determinant is same as determinant of A into determinant of B. So we can have this as determinant of A into determinant of adjoint of A. Determinant of A is 4. And determinant of adjoint is determinant of A whole power n minus 1. So 4 times of determinant of A is 4 and n is 3. So 3 minus 1 will be 2. 4 square 16. 4 6 are 24. 4 4 5 6. Yeah, 64 is the correct answer. Yes, Ananya Manikandan, 64 is the correct answer. Now we are going with the question number 58. That will be the last problem from determinants. 59 is again on the system of equation on adjoint A into B, means A into adjoint B. Whether it is 0, what will happen, all that we have already discussed. 3 questions they have asked. So now, moving on to the last question of this chapter, 58. If A is equal to, oh, I think already I wrote here. Yeah, here it is. Come on, comment 58 question solution. I'm waiting. It's here. No one? Minus 250, Harini says. Okay, let's comment. See, here we have got product of 3 matrices A, B, and B transpose. So by using this, no, if you have a product of 3, it is again individually can write. So this will be product of A, then determinant of B, then determinant of B transpose. What is determinant of A from here? Plus minus 1 2s are 2 minus 3 4s are 12. So answer is minus 10. What is determinant of B from here? Again plus minus 2 2s are 4 minus minus plus 1. 4 plus 1 is 5. So and don't forget determinant of A and determinant of B transpose both are equal. So this is also 5 as determinant of B and B transpose are what? Same. So determinant of A is minus 10. B is 5. Again 5. 5 5s are 25 with 0 here. So minus. Minus 250 is the answer. Yes, you are right, Harini. So let's check once. Have a pending any problem. This is option Bablu. So with this, we come to an end for determinants as well. 59th will be assignment. So inverse trigonometry, I thought I will take today, but we'll try to what we can we continue the class, or we'll take next class. What do you say? I hope it's visible. Yes, kindly comment. Next class. Okay, next class. Fine. I'll surely inform in the kindly go to know. I'll just decide the day and we'll let you know. I'll surely in the description in the chat box of this section I'll mention the time and the date of the next section. Okay. So before winding up, any doubts, any queries from your end? Yes. Any doubts and any queries or any queries? I hope you have also applied for CET. Okay. I think better at the earliest. Again, they have extended the date, extend the date, complete it, apply it, verification from college, all you complete the process. Don't delay. First priority you give for that and wind up the things. Okay, fine. So no doubts. Fine. Okay, fine. We'll stop the class here. So fine. Let us wind up the class here. So make sure study well, give you 100%, be dedicated. We are left with the chapter for 1 marker is inverse trigonometric function, probability, vector, and 3D. LBV, there's no 1 marker going to be asked in annual board examination. But even coming to PU board, I think we have got some chapters that is differential equation, vector, 3D, and probability. That also we will try to upload coming week. Okay, fine. So all the very best. Do well, give you 100%, and be dedicated towards the studies. I think hardly I've got 4 to 5 days coming. Just Saturday, no? Today Sunday, so only 5 more days. Yeah, Monday, Tuesday, Wednesday, Thursday, Friday. Only 5 more days. So give you 100%. Be dedicated. Don't get nervous. Don't get panic. Just whatever the knowledge you are gaining, for that you have to know where you stand. You are going to just judge your knowledge. Okay. All the very best. Do well. Thank you for your overwhelming support. God bless you all. Study well and all the very best. So finally, do like, share, and subscribe to our YouTube channel, Math Universe with Dr. Naseer Ahmed. Thank you all.